You're chilling in Hawaii, on the island of Oahu. A friend calls you up. Hey, I'm here too. Meet me in Maui. Great, but how do you get there? Your first thought is probably to take a ferry, but that's impossible. Hawaii is a pretty unique place. It's the most expensive state to live in. It has its own official language besides English. And it's the only American state made up entirely of islands. Hawaii has a total of 137 islands. 8 are the main ones, but only 6 are open to tourists. And the distance between those islands is probably bigger than you'd expect. For example, traveling from Oahu to the Big Island is around 185 miles, which is about the same distance as Chicago to Indianapolis. You might be surprised that you can't make that trip by boat. In fact, the only ferry system that actually takes passengers in Hawaii runs between Maui and Lanai. That's it. So your only option is to travel between islands is by plane. Honestly, it's a little surprising, especially considering how many people visit Hawaii every year. Tourism pretty much drives their economy, and in the first 8 months of 2024 alone, over 6 million people visited its beautiful beaches. Knowing that, we would expect Hawaii to set up a good ferry system to make it easier for visitors to get around. Just like in Greece. This would probably boost tourism even more, bringing more money to the state. But believe me, authorities and private companies also know that. In fact, they've already tried it. Ferries were a big way of getting around in Hawaii from the 19th century up until the 1950s. Since then, there have been a few attempts to bring back a ferry service, but unfortunately, they have all failed. One of the biggest attempts was the Hawaii Super Ferry, which aimed to provide a fast, affordable boat service between islands. It could carry almost 900 passengers and even allow them to bring their own cars along. The trial run started in 2007, and people were excited, but it turned into a big fiasco. A bunch of legal and environmental issues came up, like concerns about the impact on marine life, especially whales. The courts decided the ferry didn't go through the proper environmental reviews, and that caused a lot of trouble. By 2009, after tons of protests and setbacks, they had to shut it down. If a project like this comes up again, it will probably fail one more time. And there are a few reasons why it's almost impossible to set up a regular ferry system there. Let's start by talking about Hawaii's rough waters. They are deep and wild. Take the Alenoiaha Channel, for example. It's a 30-mile stretch that separates Maui from the Big Island. Its name means Great Billow Smashing Channel, and it lives up to that. It's over 6,000 feet deep, making it one of the most dangerous stretches of water on Earth. The wind there is also super strong, the fastest in Hawaii's coastal waters. But it's not any easier in the rest of the archipelago. The whole region gets hit by storms from the Pacific up north, sending big waves crashing into the islands and making the waters rough and unpredictable. Swells can come from 3, 4, or even more directions, making the sea feel really choppy. Someone who's not used to taking ferry boats would definitely find that, well, uncomfortable, to say the least. To deal with rough seas like this, the ferries have to be really big and strong. But that also makes them more expensive and harder to run than the ones in places like Alaska or Washington State. Another reason it's so tough to set up this system today has to do with marine life. A big ship moving through the shallower waters when docking could really damage the local ecosystem. And there's also the problem that the sea routes are also the migration paths of many sea animals, like humpback whales and spinner dolphins. Not to mention, ferry services can make it easier to spread harmful plants and animals, what experts call invasive species. See, Hawaii's ecosystem is super unique because it's been isolated out in the middle of the Pacific. When we talk about plants and animals that are native to Hawaii, we mean they got there on their own, no humans involved. They arrived with the help of waves, wind, or even birds flying over. But events like these are super rare. So for over 70 million years, their plants and animals didn't have to deal with outside competition. That's made them really fragile. So, when new species get brought in by us, it can be a big problem, and they could end up harming the environment. Hawaii's already been battling invasive species like fire ants, coqui frogs, and meconium, a fast-growing plant from South America that takes over native forests. People there worry that ferries, which carry cars and cargo between islands, could accidentally spread these invaders even more. Like we mentioned at the beginning of the video, the long distances between their lands don't really help either. For example, if you were to travel from Oahu to the big island of Hawaii by boat, it would take around 30 hours, and that's without any stops. The same trip by plane takes about 50 minutes. Ferries that cover long distances are much more expensive, so they need a much bigger demand to make them profitable. On top of that, the state doesn't really have the infrastructure, like enough ports and terminals to support the operations. So setting up new routes is pretty much out of the question. Airplanes, on the other hand, are a different story. The air travel industry in Hawaii is already well established and super competitive. That means flying is still the most practical option in Hawaii. Planes are quick, they don't make you seasick, and are pretty affordable, usually costing around $100 for a round trip. Okay, but what do the locals think about all this? Well, apparently, there isn't a huge demand for residents to commute between the islands all that often. Oahu is the busiest island in Hawaii, with about 70% of the state's population living there. It is where Honolulu, the capital, is located, and where most of the state's business happens. So, people from the other islands usually come over for a specific doctor's appointment or to catch a big concert. And that might happen once or twice a year, no more than that. So, even if people could choose between taking a ferry and a plane for these special occasions, most of them would probably still prefer flying. There are plenty of options between the main island airports. Planes usually start flying around 5 in the morning, and there are flights available every hour until the last one, which is usually at 9 in the evening. If you've been dreaming of going to this paradisiacal place but are worried about spending too much on plane tickets, I have some tips for you. First off, keep in mind that visiting all the main islands in 5 days or less is way too ambitious. So, if you don't have much time to spend there, think about your priorities. Each of the 6 islands open to tourists has its own vibe and activities. But you don't need to visit them all in one trip, and you can save some money by sticking to fewer islands. You can still explore the diversity of the islands by picking 2 that offer a nice contrast to each other. For example, while Oahu has that bustling city energy, Kauai has a much more relaxed vibe. Also, flights in the morning are usually cheaper, and it might be better to fly on a weekday rather than the weekend, although the price difference isn't usually huge. Hopefully these tips will save you some cash while still having an unforgettable island hopping adventure in Hawaii. Don't forget to share this video with a friend who's also dreaming of exploring these amazing islands.
If you wander about 1,800 miles from Madagascar into the middle of, well, basically nowhere, you'll reach the Kerguelen Islands. This remote French territory is one of the most isolated places on Earth. There's no airport, no native population, not even Wi-Fi, just brutal winds, freezing rain, and rough seas. But this place also hides a massive secret beneath the water, because what you perceive above sea level is only the tip of something far bigger, the peaks of an enormous landmass that mostly sank into the ocean. We're talking about the Kerguelen Plateau, a lost, sunken continent. This is a big, mostly submerged volcanic plateau in the southern Indian Ocean. It sits about 1,900 miles southwest of Australia and is nearly 3 times the size of Japan. But don't bother trying to spot it on a world map, because to really see it, you'd have to dive deep. And I mean that literally, since big chunks of it now lie more than 6,000 feet under the ocean. Now, it wasn't always like this, though. For long stretches of time, large parts of the Kerguelen Plateau were above sea level, forming a huge microcontinent. That was roughly between 100 million and 20 million years ago. Back then, scientists think this land was covered in dense forests, packed with trees like araucarias and cypresses. But it wasn't exactly peaceful. Active volcanoes were everywhere, with lava flows probably spilling across the land. And not to mention the dinosaurs. There's some evidence that lizards and dinosaurs once lived there, but they were likely the smaller ones, not the big scary kind. Another cool theory is that the Kerguelen Plateau once acted like a long land bridge connecting Antarctica and India. People believe that for a long time, but more recent research suggests it's probably not true. Even back then, there were still huge stretches of open water separating these landmasses. But anyway, today the trees are gone, and those ancient volcanoes are quiet, hidden underwater. So, you might be wondering, how did this whole chunk of continent sink and basically disappear? Well, we'll get to that in a second. But first, we need to answer a basic question. How did the Kerguelen Plateau form in the first place? Well, our story starts about 130 million years ago. Back then, Earth had Gondwana, a giant supercontinent that included what are now South America, Africa, India, Australia, and Antarctica. But eventually, it began to break apart. And during that long, dramatic breakup that happened over millions of years, the Kerguelen Plateau was born. And it basically exists thanks to something called the Kerguelen Hotspot. The Kerguelen Hotspot is a region deep inside Earth where super hot melted rock slowly rises toward the surface. You can think of it like a steady underground burner, melting rock in the same spot for a very, very long time. And even though the hotspot stays put, Earth's outer shell keeps moving above it. So as the seafloor drifted over the Kerguelen hotspot, huge amounts of melted rock spilled out, cooled down, and stacked up, layer after layer. Over about 30 million years, that process built a massive mound of volcanic rock on the ocean floor. At the peak of the eruptions, it may have added around 7 to 8 inches of lava every year. To put that into perspective, that's enough new lava to fill about 184,000 Olympic-sized swimming pools, if there were that many. And little by little, that volcanic pile kept growing, bigger and bigger, higher and higher, until it finally rose above sea level and became the Kerguelen Plateau. But then, something strange happened. Over the last 20 million years, this landmass started to sink, slowly but steadily. Today, most of it sits roughly 3,300 to 6,600 feet below sea level, and only a couple of spots have managed to stay above water. One of them is the Kerguelen Islands, that French territory we mentioned earlier, and the other is the McDonald Islands, which belong to Australia. Okay, but how did all the rest of it sink? Well, continents don't end up underwater because they suddenly drop like stones. Instead, this process happens because Earth's surface slowly bends, stretches, and shifts over very long periods of time. The outer shell of the planet is broken into huge pieces, the tectonic plates. These plates float on a hotter, softer layer of rock beneath them, known as the mantle. When a continent gets pulled apart by forces deep inside Earth, its crust stretches out, gets thinner, so it starts to sit lower. And as it drops, the ocean doesn't come rushing in all at once. Instead, seawater slowly spills over the edges, flooding the lowest areas first and turning dry land into shallow seas. Meanwhile, the rock underneath cools down, and when it cools, it contracts and sinks, which pulls the surface down even more. On top of that, sediments keep piling up, almost like heavy blankets, adding extra weight and pushing the crust lower and lower. And that's basically what happened to the Kerguelen Plateau. Parts of it once rose above sea level and even had forest, but the sheer weight of all that basalt, along with shifting tectonic plates, gradually pushed it back down into the deep ocean. In the end, only the highest volcanic peaks stayed above water, and those are the islands we see today. Now, here's a big question. If most of it is underwater, can we still call it a continent? Well, in a way, yeah. In fact, scientists have described it as a microcontinent since the 1970s. And that's because what really separates continents from ocean basins isn't whether they're above water, it's the type of crust underneath. Earth basically has two main kinds of crust, rising and deep dish. Wait a minute, that's pizza crust. Oops. The Earth's crust comes in either continental or oceanic. Continents are made of continental crust. It's thicker, lighter, and usually much older, so it tends to sit higher and form land. It's also more granite-like in composition, formed from magma that cools slowly deep underground before it hardens. Then there's oceanic crust. That's what the ocean floor is made of. It's thinner, heavier, and much younger, so it sits lower and stays underwater. And it's mostly made of basalt, formed when rock in the Earth's mantle melts and rises up. Now here's where the Kerguelen Plateau gets really interesting. Even though the whole region is basically underwater, it isn't just normal ocean floor. And even though it's built from huge amounts of basalt, it doesn't behave like typical oceanic crust. Since this basalt was piled up over millions of years, the crust there became much thicker than normal oceanic crust. It also contains fragments of continental crust from the breakup of Gondwana. So that's basically why we consider it a continent. But you're not going to see the Kerguelen Plateau listed as one of Earth's main continents, just like Europe or Africa. And honestly, it's mostly because it would be a headache. A lot of people don't realize this, but the way we label continents is based more on convention than on one strict scientific rule. Because if we started teaching that the Kerguelen Plateau counts as a continent, we'd have to take a serious look at a bunch of other places too, like Zealandia, this almost completely submerged chunk of continental crust in Oceania. And it doesn't stop there. There's Beringia, Doggerland, Mauritia, Sahul, and Sunda, all regions that were once dry land or made of continental crust, but are now partly underwater. So, imagine if we started calling all of them continents. Earth would go from having 7 continents to what, 10, 12, more? It would get confusing fast. That's why the Kerguelen Plateau is usually described as a microcontinent or a sunken continent, not like a full continent, and certainly never an incontinent. That doesn't make it any less interesting, though. These days, the area is still volcanically active. The eruption rate dropped a lot over time and has stayed relatively low ever since, but the system is still going. And that's already pretty wild, because activity like this usually only lasts 1 to 5 million years. So, in a way, the Kerguelen Plateau behaves like one of Earth's longest-running supervolcano systems. And it's still not done. If you look up a flight tracker map of the world, you can notice one interesting thing. Across the North Atlantic, the screen glows with thousands of planes flying between North America and Europe. But if you shift your gaze down toward the South Atlantic, there's almost nothing. Just a handful of lonely planes dot the screen. So why is it that one half of the Atlantic is as packed as a shopping mall on Black Friday, and the other is as deserted as a forgotten parking lot? The answer isn't just about distance or geography. It's a mix of history, economics, culture, and even how our imaginations of connection were built in the first place. For starters, the way flight networks evolved wasn't a natural process. No one built Africa's transport systems to connect Africans with South Americans across the ocean. They designed them like spokes on a wheel, all pointing toward Europe. Ports, railways, airports, everything was meant to ship goods, labor, and wealth northward, not sideways across the Atlantic. That means even after the Age of Independence, most of the air routes out of Africa led to Paris, London, Lisbon, or Brussels, not Rio de Janeiro or Buenos Aires. South America followed a similar script and built stronger ties with Europe and the United States than with Africa. The result? The South Atlantic never really got the chance to become an air superhighway in the first place. Then, whether we like it or not, airlines follow money like bees follow honey. Planes just don't go anywhere. They go where demand exists. The North Atlantic sits between two of the richest, most interconnected economies in the world, Europe and North America. Billions in trade, finance, tech, education, and migration flow back and forth across this stretch every single day. Engineers shuttle between Silicon Valley and London. Students fill planes between Boston and Paris. Tourists flood in both directions. That translates to around 500 flights every day between the US and Western Europe alone, and over 10,000 flights a week between North America and Europe. Meanwhile, the South Atlantic connects two regions that are dynamic in their own right, but don't trade as intensely with each other. Africa ships raw materials, mainly to Europe and Asia, and South America's main trade partners are North America, Europe, and China. The two continents don't really need each other on a day-to-day basis, which means there's not much demand to fill a fleet of airplanes. Migration patterns add to the deal. When people move, airlines follow, because where families stretch, flights connect. In the North Atlantic, you've got centuries of migration weaving tight family ties across the ocean. There are Irish families in Boston, Italians in New York, Germans in Chicago, and many other examples. Add in business expats, international students, and professionals, and suddenly there's an endless need for flights back and forth. The South Atlantic, by contrast, doesn't have the same migration history. Sure, the African diaspora in Brazil is massive, but much of that goes back centuries, so there's not so much modern voluntary migration that keeps up steady traffic today. In the modern era, doctors, engineers, and students from both Africa and South America usually set their sights on the US, Canada, or Europe, rather than hopping across to each other's continent. Without those migration-driven visiting relatives or returning students, the passenger base just doesn't exist. Tourism is another missing piece. Americans cross the Atlantic to sip espresso in Rome or visit London's museums, and Europeans head west to hit Disney World or road trip across Route 66. It's an entire industry with cheap flights and cultural ties. In contrast, South America and Africa don't have the same setup. A Brazilian tourist doesn't usually dream of heading to Ghana for vacation, just like a Kenyan backpacker isn't exactly booking a weekend in Sao Paulo. Language divides, cultural distance, and weaker tourism marketing all make it less appealing. Plus, costs are higher and flight options are scarce, so why would someone bother? Without a steady stream of leisure travelers, airlines aren't crazy about carving out new routes across the South Atlantic. Now, geography adds its own dose of irony. On paper, Africa and South America aren't that far apart. At their closest points, Brazil to West Africa, is actually shorter than some North Atlantic routes. But the cities that generate passengers are not sitting neatly on those edges. Major hubs, such as Sao Paulo or Buenos Aires, are deeper into South America. On the African side, hubs like Johannesburg and Nairobi are hundreds or even thousands of miles from the coast. That means a direct Sao Paulo-Johannesburg flight isn't just crossing an ocean. It's crossing an ocean plus a huge chunk of land on the African side. That jacks up the distance and the cost and makes it harder to fill planes profitably. So when you compare that to New York-London or Paris-Toronto, you see why more people choose these shorter direct hops between economic capitals. Now, even the weather throws in obstacles. The North Atlantic has a neat trick up its sleeve, the jet stream. These faster-moving air currents help push planes across the ocean and shave hours off flights and save tons of fuel. The South Atlantic is not so lucky in this way. It doesn't have a similar jet stream pattern running neatly across its width, so flights burn more fuel and take longer without getting the same free ride. Plus, there are fewer alternate airports along the way in case of emergencies. Modern planes can cross the ocean easily, but still, safety matters. The North Atlantic is dotted with islands like Iceland, Greenland, the Azores, and Bermuda, which double as emergency stopovers. They are the backup options if something goes wrong. But the South Atlantic, outside of a few remote islands like Ascension or St. Helena, is a vast stretch of water with nowhere to land in a pinch. It does make things more complicated and routes less attractive when you weigh against potential costs and risks. Meanwhile, infrastructure plays its part too. Europe and North America have some of the busiest, best-connected airports in the world. They get constantly upgraded to handle huge flows of passengers and cargo. By contrast, many airports in Africa and South America are improving, but they still don't have the same connectivity and can't accept the same number of passengers. Routes rely heavily on big hubs to feed passengers in and out, and if those hubs aren't strong enough, the routes struggle. Alliances sneak in as well. It's not just demand that shapes airline networks. There are also agreements. I mean, who's allowed to fly where and with which partners. Open skies agreements and powerful alliances like oneworld, Star Alliance, and SkyTeam rule the North Atlantic. They coordinate routes, schedules, and ticketing to make flights seamless. South America and Africa still don't share that level of coordination. Now finally, it comes down to psychology as much as economics. Flying is about more than just getting from point A to point B. It's also where people feel connected. The North Atlantic wins from centuries of cultural intertwining: music, movies, shared history, business, and family. The South Atlantic feels worlds apart in the global imagination. When someone from Sao Paulo dreams of going abroad, they will most likely picture New York, but still not Luanda or Dakar. And when someone in Lagos dreams of foreign travel, they will more likely imagine London, not Buenos Aires. There are some parts of the world that are practically off the radar when it comes to air traffic. The polar regions, like the Arctic and Antarctica, have almost no commercial flights. Planes mostly stick to research stations or very specific northern routes. Out in the Pacific, especially the South Pacific, between some islands in French Polynesia, flights are also rare and not always seem logical. Even in South America, commercial air travel mostly skips the Amazon rainforest regions of Brazil and Peru. Maybe it'll change in the future, but so far, the North Atlantic is like a busy interstate highway, and these southern regions are more like calm back roads.
It's one of America's strangest contradictions. The Northeast, the cradle of cities, commerce, and crowds, hides a vast, empty wilderness at its northern edge. Millions live packed together to the south, yet up here, there's space for everyone, and almost no one takes it. How did this happen? How did the heart of America's most crowded region end up with one of its loneliest frontiers? The northeastern United States is home to more than 50 million people. It's one of the busiest and most densely packed regions in all of America. But almost 90% of those people live in the southern half of it. If you go north, past big cities and highways, everything will change. The noise will fade and the lights will thin out. You'll find yourself in a different world, a quiet land of forests, lakes, and mountains, stretching across northern New York, Vermont, New Hampshire, and Maine. This is America's empty Northeast. And the mystery is simple. Why is this part of one of the most crowded regions in the country so empty? First of all, let's take a look at New England itself. Massachusetts and Rhode Island are bursting at the seams, while Maine, Vermont, and New Hampshire feel wide open. Connecticut sits in the middle, literally and figuratively. Massachusetts is basically the crowd magnet. Most people live around Boston and the cities nearby, Cambridge, Worcester, Springfield, where everything's close, busy, and built up. Rhode Island may be tiny, but it's got a big city density. Connecticut sits right between Boston and New York, and it shows. It has a busy coastline and quieter inland towns. It's not too crowded and not too empty. The middle ground. Once you cross into New Hampshire, things slow down. There's Manchester and Nashua, but most of the state is forests, lakes, and open land. Then there's Vermont, easily the least crowded region of the bunch. The Green Mountains slice through the middle, and most people live in small towns or villages. And Maine is huge and mostly empty. Most people stick to the southern coast. If you head north, you'll hit endless forests, lakes, and long, quiet roads. It's beautiful, but it feels like the edge of the map. Today, the northern half of the Northeast, northern New York, Vermont, New Hampshire, and Maine, holds only about 4.9 million people. That's roughly the same as the population of the Boston metro area alone. To put that in perspective, if you take southern New York and southern New England, about the same land area, you get 10 times as many people living there. So, why the gap? It all comes back to geography, history, and economics. and how they've always worked together to keep the North empty. Let's start with the land itself. The thing is, the farther north you go, the rougher the land gets. Southern New England and downstate New York are full of rolling hills, wide valleys, and coastal plains. But then come the mountains. They're old, crumbling, and wild. In northern New York, you'll see the Adirondacks. To their east, the Green Mountains run up the middle of Vermont, stretching into Quebec. Keep going and you hit the White Mountains of New Hampshire. They're home to Mount Washington, famous for some of the most severe weather on Earth. And beyond that, the western Maine Mountains roll on toward Canada. Those aren't gentle hills, they're real barriers, and they owe their shape to one of the most powerful forces in Earth's history: ice. During the last ice age, huge glaciers covered this land. When they finally retreated, they carved out deep valleys and left behind thin, rocky soil. Later, the basins filled with water, creating thousands of lakes and ponds. It's a beautiful but difficult land to live on. Farming never stood a chance here the way it did farther south, where the soil is way richer. So the mountains stayed wild, covered in dense forests that even today stretch for miles. Northern Maine and the Adirondacks together make up one of the largest continuous forests east of the Mississippi. For centuries, people have come here to cut timber, fish, or hunt, but never in great numbers. And then there's the weather. Up here, winters are long, dark, and cold. Snow piles up early and doesn't leave easily. Summers are short, and the growing season is barely long enough to farm. It's not exactly a place that says, "Come start a new life." But of course, some people did. And here's where history comes into play. Long before Europeans arrived, this land was home to indigenous nations. The Abenaki, living across Vermont, New Hampshire, and Maine, had complex trade routes, connecting their communities all the way from modern Quebec to Massachusetts. Farther west, the powerful Iroquois Confederacy extended its influence toward the Adirondacks, controlling vast hunting grounds and trade routes. Then came the Europeans. In the 1600s, French explorers and fur traders pushed south from Quebec. They set up outposts along rivers and lakes that linked the region to Canada. They saw opportunity: furs, fish, timber, but not farmland. The dense forests and harsh winters kept settlements small and scattered. The English, expanding north from the Massachusetts Bay Colony, took to the coast. They settled in southern Maine and New Hampshire, but going inland was another story. Between the cold, the forests, and the resistance from native nations, their progress was slow and dangerous. For more than a century, the interior of the northern Northeast stayed wild. Later, around the 1760s, the British took control of the region. Land speculators moved in, especially in Vermont, which both New York and New Hampshire claimed as their own. The overlapping claims led to chaos, and eventually, Vermont declared itself an independent republic in 1777. For 14 years, it existed on its own until it joined the United States in 1791 as the 14th state. New Hampshire pushed inland from the coast, building towns in the valleys between its granite mountains. Maine, meanwhile, spent centuries as parts of Massachusetts. Its economy ran on timber and shipbuilding. Trees turned into masts and planks for the growing British and later American navies. And in northern New York, the Adirondacks remained a wild frontier long after the rest of the state filled up. The land was too rugged and the winters too fierce. Logging, mining, and later tourism would bring people north, but never in huge numbers. By the mid-1800s, the southern parts of New England were booming. Cities were growing, factories were humming, and immigrants were arriving in large numbers. But the northern regions stayed quiet. So as we now know, the mountains are the first big barrier. They make everything harder: travel, building, farming, and surviving winter. The soil is thin, rocky, and poor. And what's underneath isn't much better. The region doesn't have rich mineral deposits or coal seams like the Appalachians farther south. Without valuable resources to mine or easy land to farm, there wasn't much reason for settlers to stay. That was one of the reasons why the economy never took off. The empty Northeast never became a center of industry. Southern New England had rivers that powered early factories, ports connected it to global trade, and the cities attracted millions of immigrants. Northern New England and Northern New York had none of that. They had lumber, granite, and paper mills, all useful, but those industries didn't create huge cities. Even today, the economy up there relies on the same resources, along with tourism. People come to hike, ski, fish, and escape city life, but most don't stay year-round. Towns fill up in summer and fall, then empty out when the snow starts falling. A few small cities, Portland, Burlington, Manchester, thrive, but there's no Boston or New York up here. You won't find massive universities, corporate headquarters, or international airports to pull in young people and families. In fact, some states have gone so far as to pay people to move there. Maine and Vermont have both launched programs offering money to remote workers who relocate. That's a pretty desperate attempt to reverse decades of population decline. Today, this empty Northeast holds just about 1% of America's population. It's a land of deep woods, icy lakes, and quiet towns. The wilderness never really left this region, but that stillness is also what makes this place so special. The rest of the Northeast is filled with constant noise and motion. Meanwhile, the North is a reminder of what the region once was: wild, cold, and untamed. That's how the heart of America's most crowded region remains one of its last true frontiers. Canada is massive, but almost everyone lives in the east or the west. And right in the middle, there is this huge stretch of land where hardly anyone calls home: Northern Ontario. So why does this place almost feel off-limits? Northern Ontario is part of, well, Ontario. It's a super busy province, home to major cities like Toronto and Ottawa. About 1/3 of all Canadians live there, but most of them are down in the southern part of the province, not up north. But that doesn't really add up when you think about it, because the northern part is way, way bigger. We're talking about a region that is more than 300,000 square miles, pretty much the same size as the whole country of Turkey. Northern Ontario takes up about 87% of the entire province, but strangely, only about 6% of Ontario's population lives in this area. But before you start dreaming about moving there for some peace and quiet, hold on. There are 4 big reasons people choose not to, and honestly, you'll probably agree. Reason number 1, the land itself. Look up the region on Google Earth, and all you will see is a huge stretch of empty space. Nothing special at first glance, but zoom in, and that's when things start getting complicated. Northern Ontario is famous for its rugged, remote landscapes, full of endless forests and lakes. It's beautiful to look at or snap a photo of, but living there is a whole different story. The geography makes the area tough to get around and makes it hard to build things like transportation routes and railways. And since it's so difficult to put decent roads up there, the whole region stays pretty isolated. That takes us to reason number 2, remoteness. You might think that, being in the center of the country, it could serve as a great link between the eastern and western parts of Canada. But in reality, that's not how it works, and the region is very far from Canada's major cities. Take Greater Sudbury, the largest city in Northern Ontario, with around 160,000 people. The closest major city is Toronto, which is about 230 miles away. So yeah, that's roughly a 4-hour drive just to get there. If you're planning a holiday weekend in a big, dynamic city, a 4-hour drive sounds like a fun road trip. But if you need to go for a dental appointment or sort out paperwork, that distance suddenly feels endless, not to mention the cost. Unfortunately, that's how life is for many people up there. Residents of Northern Ontario don't have easy access to opportunities or services. With so few people scattered across such a huge area, the region doesn't have enough facilities, infrastructure, or easy access to essential services like healthcare and education. People there sometimes have to deal with poor or even non-existent infrastructure, like missing roads, airports, hospitals, and schools. Without those things, settling down is really tough. And in rural areas, it's even worse, because the lack of services can seriously hurt their quality of life. Psychologically speaking, that's not great either. People can end up feeling isolated and lonely, and the freezing weather doesn't help. Which brings us to reason number 3 why most people don't live in Northern Ontario: the harsh climate. If you're not a fan of cold weather, you should definitely leave this region off your travel bucket list. Winters up there can be long and brutal, with temperatures sometimes dropping as low as 40 degrees below 0 Fahrenheit. Have you ever tried shoveling snow when it's this cold? Yeah, it's not exactly fun. That kind of harsh weather doesn't just mess up your weekend plans or your daily jog. It also makes transportation a huge challenge. The result is that many residents end up isolated from essential services and job opportunities. And it's also really hard to build infrastructure, grow industries, or run businesses because of that harsh climate. Take farming, for example. Compared to Southern Ontario, the Northern region has a shorter growing season and much colder weather. Although crops like oats, potatoes, and green beans can handle the cold, the climate usually limits the variety of things that can be grown. That's why most farms are concentrated in the southern part of the province, and in other parts of the country, like the prairies and Quebec. Anyway, that's just one example of how the climate makes it tough for people to build a strong foundation to support themselves. And that's exactly the 4th reason why Northern Ontario is so empty: the economy. It's not that there aren't any jobs available. In fact, there are plenty. In 2023, the northern part of Ontario had some of the highest job vacancy rates in the country. So unlike in many parts of the world, it's a place where they have tons of jobs available, but no people to fill them. One reason people don't take those jobs is that many of them are older. Just look at Elliott Lake, for example. 42% of the people living in the city are over 65 years old. That's the 3rd highest concentration of older adults anywhere in Canada. But it's not all that different in the rest of the region either. Estimates show that by 2036, people aged 65 and older will make up almost 30% of Northern Ontario's total population. And you see what happens when they hit 65, right? They've got their pensions, and going back to work just isn't on the radar. This problem only gets worse because young people just don't seem interested in living there. Every year, lots of students around 17 or 18 years old pack their bags and either drive across the province or fly across the country to study somewhere away from their northern homes. And many of them don't come back. But that's actually pretty strange considering the region does have a strong economy, especially in mining. Take the Red Lake area, for example. It's packed with gold. In fact, it's home to one of the richest gold deposits in the world and has already turned out over 30 million ounces of the metal. That's definitely helped Canada stay ranked among the top 5 gold-producing countries in the world. Then, there's this region, known as the Ring of Fire. It's centered around McFalds Lake in the Kenora district and covers about 1,900 square miles. It's rich in valuable minerals like chromite, cobalt, nickel, copper, and platinum. These days, Northern Ontario's mining industry is making a big comeback and attracting new investments. That's happening because the world is suddenly desperately looking for critical minerals. By that, I mean essential elements used in modern technologies like smartphones and renewable energy systems. Minerals like cobalt, nickel, and copper are especially important for making the batteries that power electric cars, for example. So, right now, it seems like the whole mining scene in the region is doing pretty well, but the industry has gone through plenty of ups and downs, with fluctuations and periods of decline. And that, combined with the possible lack of variety and jobs outside the mining industry, means people are more likely to leave the region in search of better opportunities. Interestingly though, mining companies are now struggling to find enough skilled workers in Northern Ontario. And that's probably because of all the reasons we've already talked about: an older population, harsh weather, tough geography, and a long distance from major urban centers. So, it's basically a cycle. and local authorities are trying to break out of it by improving infrastructure in the region, offering more incentives, and finding ways to keep young workers from leaving. Some of their strategies include offering cash rewards to people who refer healthcare workers for job openings or providing tax-free payments to help cover higher home energy costs. And there are plenty of other initiatives too. So yeah, with strategies like these, it's definitely possible to grow the population there. And who knows, maybe one day this region could be bustling with people. Something strange is happening in Egypt's desert. Giant, mysterious green circles are popping up everywhere, hundreds of them. And then you've got dozens of canals and roads connecting into something that looks like a river. But it's not exactly that. This is the ambitious New Delta project, and it has one controversial goal: to flood the desert. It's easy to see why. More than 90% of Egypt is desert, miles and miles of sand dunes and dry land under scorching heat. Almost nothing can grow there. So today there are basically only two areas where Egypt can grow large amounts of food: the Nile Valley and the Nile Delta. Together they cover only about 5% of the country's land, but their crops feed about 99% of Egyptians, and that's becoming a real problem because Egypt's population keeps growing. By 2050, estimates say their population will grow by about 40 million people, reaching nearly 160 million. The Nile Valley and the Nile Delta just won't be enough to handle that kind of demand. See the problem here, right? The population is growing, people need more food. But most of the country is desert, and there's not much room for new farms. So what can they do? The easy solution is the same one you use when your fridge is empty. You order in. Egypt does that too. They buy huge amounts of food from other countries. But importing food is expensive and time-consuming. So they need to create more space for farms. And they need it fast. That's where the New Delta project comes in. This is a massive agricultural plan meant to turn parts of the desert into green fields. The idea is to move water and farming west of the Nile. And if it works, it could expand Egypt's farmland by about 15%. Sounds great on paper, right? But in reality, this plan comes with a lot of controversy. Their idea is to create an artificial river right in the middle of the desert, about 70 miles long. To make it work, they're building tons of roads and canals to support it. And those strange green circles I mentioned earlier are irrigation systems. They pull water up from wells or pipelines, then slowly spin around and spray water in a big circle over the crops. Okay, so we've got this huge artificial river being built in the middle of the desert, but where is all that water coming from? Well, it comes from three main sources. The first, and by far the biggest, is treated wastewater. They take used water, the kind that goes down sinks and toilets in our homes, for example, and clean it up so it can be used safely again. To do that, they had to build a modern treatment plant in El Hammam, a town in Egypt's northern coast west of Alexandria. Its construction was completed in 2023, and it's absolutely massive. It's so big that it now holds the world record as the largest wastewater treatment plant in the world. It cleans an enormous amount of water every day, enough to fill about 3,000 Olympic-sized swimming pools, and most of that water goes straight to farming. The second source of water comes from the Nile. Basically, they're taking water from Egypt's most famous river, sending it through massive canals and pushing it deep into the desert, into this new, man-made river. Finally, the third source is deep fossil groundwater. In other words, it's water from way under the desert. Down there is something called the Nubian Sandstone Aquifer, basically a huge underground reserve of water that's been trapped for thousands of years. And this is where the controversy starts. It's true that there's a lot of water under the western desert, but it's limited. Because this is fossil water, I mean it's so old that it doesn't really get replaced. Once you pump it out, it won't refill anytime soon, not in our lifetime, and probably not even for many generations. On top of that, the deeper you drill, the saltier the water can get, and we don't want that. You see, most crops don't like salt. If the water is too salty, plants grow slower, give smaller harvests, or dry out. And when you keep watering with salty water, salt builds up in the soil. The water evaporates, but the salt stays. Over time, the land can turn hard, dry, and basically useless for farming. So pumping groundwater might help in the short term, but it raises a big question. Is this really doable in the long run? And there are other concerns too. The project was sold as a big win. Grow more food, create more jobs, and help Egyptians. It also boosts the economy because they're growing expensive fruits and vegetables that get sold abroad to places like Canada, Australia, and Japan. But that's also the problem. Many people complain that the project is mostly about growing crops to sell abroad. And sure, exports bring money into the country in the big picture, but that doesn't necessarily mean food gets cheaper at home or that poorer families can afford more. Because even though it has boosted exports, it hasn't done much to prevent massive food price inflation inside the country. So, Egypt's food security problem still isn't fully solved. Many Egyptians are still dealing with high prices and tight budgets. Another controversial thing is that no one knows how much this project actually costs. The press sometimes mentions $5.2 billion, but some experts put the total closer to $9.7 billion. Just the wastewater treatment part alone is said to cost more than $500 million, but it's very hard to know for sure. Journalists and researchers say there isn't much transparency, and the project's finances are tough to track. Experts also warn that farming in the desert is crazy expensive. Unlike the rich soil in the Nile Valley, the Western Desert is mostly dry sand with very few nutrients. So if you want to grow anything out there, you need tons of irrigation just to make the land workable. And powering all those irrigation systems takes a ton of energy, making farming in the desert even more expensive, even if you already have a giant artificial river to help you out. Still, some people argue the risks and the costs are worth it, and that things are starting to change. Take wheat, for example. For years, Egypt has been the #1 wheat importer in the world, and that's not exactly a title you want to win, because it costs the country billions of dollars every year. So then the new Delta project comes along, and wheat becomes one of their main targets. Egyptian authorities say it helped them cut wheat imports by 17% in 2025. That saved them around $250 million. This was such a big achievement that the world now has a new #1 wheat importer, China. And it's not just wheat. Oranges, potatoes, grapes, agriculture is booming over there. According to estimates, food exports jumped from 5 million tons in 2020 to over 8 million tons in 2024. That's why we can say the new Delta project is already changing Egypt's agriculture. And from satellite images, you can see it's changing what the country looks like too, turning dry desert into bright green patches. It's real, and the transformation is pretty dramatic. So there's no doubt this project is both an impressive engineering achievement and a huge experiment. But researchers say it's still too early to know if it will actually solve Egypt's food problem. In the end, it all depends on water, energy costs, and who gets to make the big decisions. If the Nile, treated wastewater, and fossil groundwater can be managed in a sustainable way, the project could seriously boost farming. And if not, it could drain precious water, make the gap between rich and poor even bigger, and leave behind an expensive footprint on the desert.
Now, don't be nervous, but there is a hole in our universe. Is it leaking? It's larger than anything we've seen before. The human mind can't even imagine something this huge. Well, mine sure can't. Is it a growing black hole? Is our solar system going to end up sucked into this giant nothingness? Am I blowing this all out of proportion? Well, let's figure it out. The universe isn't packed evenly with stuff. Huge empty areas, called voids, make up about 80% of it. Our own Milky Way even sits inside of one, known as the local hole. But one void is on a whole different level. It's called the Behoudi's Void, and people often nickname it the Great Nothing. It's a massive, almost empty bubble of space located far away in the Behoudi's constellation. Its sheer size makes this bizarre formation unbelievable. The Behoudi's void stretches a whopping 330 million light-years across. For comparison, our little solar system has a width a bit more than 3 light-years. Yet the Behoudi's void contains very few galaxies. Compared to the rest of the universe, it's basically empty. That makes it one of the largest known voids, and one of the biggest empty spaces we've ever found. If our galaxy were inside the Behoudi's void, we wouldn't have seen any other galaxies for most of history. Until the 1960s, our telescopes just weren't powerful enough. Other galaxies would have been way too far away and too faint to spot. It wasn't until the 1960s, when telescopes got much better, that we could finally see very faint, faraway galaxies. If we had been living inside that void, that's when we would have first realized other galaxies even existed at all. But let's figure out a very important question. How do such giant empty spaces even form? After the Big Bang, all the matter in the universe started spreading out, but it didn't spread out perfectly evenly. Tiny random differences, called quantum fluctuations, meant some areas had a little more matter than others. The denser areas had stronger gravity, so they pulled in even more matter. Over time, this left other regions almost empty. That's how galaxies clumped together, and how huge voids were created in between. So over time, galaxies attracted each other too, linking up into long thread-like structures called filaments. Together, those filaments formed a massive foam-like web across the universe. The galaxies gathered along the threads, while the empty spaces in between became voids, kind of like bubbles in foam. Smaller voids slowly merged into bigger ones, which is how enormous regions like the Behoudi's void formed. Today, filaments and voids make up the largest structures in the universe. The filaments are hotter and more energetic, while the voids are colder and much emptier. Now, the Behoudi's void is enormous. It makes up about 0.35% of the diameter of the entire observable universe. But inside this massive space, there are only about 60 galaxies, mostly stretched out in a tube-like shape through the center. Normally, a region this size would contain around 2,000 galaxies. The void is also surrounded by massive galaxy clusters, like Ursa Major, Shapley, Hercules, Corona Borealis, and Behoudi's. This makes the emptiness in the middle even more shocking. Now, scientists first noticed those huge empty spaces and big galaxy groups in the 1970s, when new technology finally let them see the universe in 3D. As for the Behoudi's void, it was discovered in 1981 by American astronomer Robert Kirshner from the University of Michigan, which also has a pretty good football team. At the time, he and his team were mapping the universe in 3D by measuring how fast galaxies were moving away from us. This method is called a redshift survey. So while doing this, they noticed something weird. A huge region of space where almost nothing showed up. It was basically a giant blank spot on the map. Scientists ruled out a few dramatic ideas right away. The Behoudi's void isn't a black hole because it does contain a small number of galaxies, just far fewer than expected. It's also not a dark nebula, which is a dense cloud of gas and dust that blocks out light. The Behoudi's void isn't hiding galaxies. There simply aren't that many to begin with. The Behoudi's void helps scientists learn how the universe changes and grows. Because it's so empty, it's a great place to study dark energy. Our universe consists of normal matter, and dark energy. Normal matter is everything you can see with your own eyes or with the help of instruments. It makes up around 5% of the universe. About 27% of the universe is dark matter, and dark energy takes up around 68%. It's a force responsible for the expansion of the universe. We really don't know what dark energy is, so scientists are excited about any chance to study it and learn more about how it works. Voids are also useful for studying neutrinos, tiny particles that can travel throughout space without getting stuck. They're often called ghost particles because they're almost impossible to catch. They fly through space and through us without leaving a mark. Right now, trillions of them are passing through your body and you don't feel a thing. Neutrinos are made in places with lots of energy, like the sun, exploding stars, and nuclear power plants. They are everywhere, second only to light particles in the universe. What makes neutrinos really strange is that they can change as they travel. They come in 3 types, and they can switch between them while moving. Scientists also don't know how much neutrinos weigh, or which type is the heaviest. Learning more about them could help explain how the universe works. Well, anyway, with time, space missions will look closely at these empty regions. By comparing what they see with computer predictions, scientists hope to learn more about neutrinos and better understand how the universe works. One of such space missions is Euclid. Its data will be used to study and analyze the Bohodi's void and other similar cosmic voids. Euclid's job is to study the dark universe. It does this by making a huge 3D map of space, looking at billions of galaxies as far as 10 billion light-years away and covering a big part of the sky. Now, scientists know that dark energy makes the universe expand faster, and dark matter helps galaxies form and stick together. But they still don't know what either of them really is. By watching how the universe has changed over the last 10 billion years, Euclid helps scientists understand how space grew, how galaxies formed, and what dark energy, dark matter, and gravity might actually be like. Euclid is about 15 feet tall and 12 feet wide. It has 2 main parts. One part runs the spacecraft, like power, computers, and steering, and the other holds the telescope and 2 cameras. One takes pictures in visible light, that's what our eyes can see. The other sees in infrared light, which helps scientists spot very distant galaxies. Now, Euclid launched on a SpaceX Falcon 9 rocket from Florida in July 2023 and officially started doing science in February 2024. It now orbits far from Earth, nearly 1 million miles away. It stays in a special spot in space where it moves with Earth around the Sun. This keeps its view stable and makes it easier to study the universe. Euclid is supposed to work for about 6 years, but it might keep going longer if it doesn't run out of fuel. In October 2024, Euclid released the first part of its huge map of the universe. Over time, it'll scan more than 1/3 of the sky outside our Milky Way galaxy, capturing billions of galaxies, some so far away that their light took up to 10 billion years just to reach us. The images taken by the space probe are about 4 times sharper than those taken by telescopes on Earth. Euclid also studies light in detail to learn what galaxies are made of and how they move. It'll do this for hundreds of millions of stars and galaxies. And all of this will create a massive space data library, one of the biggest ever made by a space mission. Oh, by the way, Euclid was named after an ancient Greek mathematician who helped invent geometry, the study of shapes in space. Scientists picked this name because understanding the shape of the universe helps explain how matter and energy are spread through space. So now you know.
Saudi Arabia wants to host the Asian Winter Games right in the middle of the desert. No more climbing frozen mountains in gear heavier than you are. No icy valleys, just camels, endless sand, and a sun that can fry an egg if you crack it on a metal plate. Let's explore one big and unexpected idea: building a futuristic ski landmark in a place where snow is treated as a big deal. Desert countries have already tried similar things. Dubai built its own ski slope inside a shopping mall almost 20 years ago. You could buy sneakers, grab a snack, and then go skiing without ever stepping outside. It blew people's minds back then, but compared to the project Trojena, it feels tiny. This is not an indoor side attraction. It's part of a roughly $500 billion plan to carve out a winter zone inside a desert region, right in the middle of real mountains. Trojena sits in the northwest corner of Saudi Arabia, in a mountain area with sharp ridges and long, empty stretches of land between them. It is one part of a much bigger strategy called NEOM. a plan to build new cities and resorts across this region. This whole zone is part of a desert belt across the Arabian Peninsula, with towns far apart and long stretches where you mostly see rock, sand, and sky. The climate here is really harsh. Summer days go past 100 degrees Fahrenheit, and by noon, the heat hits you from above and below like you're being baked. Leaving anything metal in direct sunlight is a really bad idea. Winters bring some relief, especially in the higher peaks. Nights can get pretty chilly, and now and then, those peaks pick up a thin layer of snow. It looks nice, but it doesn't stick around. It melts in a day or two before you can even take pictures, let alone think of skiing. Maybe you wonder, but why go through so much trouble just for a ski center? Well, here's the funny part. It's a lot more than just a ski center. The plan is to build an entire winter city, a place with ski runs, hotels, cable cars, housing zones, golf courses, and even a crystal-shaped tower planned to be roughly the same height as the Eiffel Tower. Trojena covers about 23 square miles with about 18.6 miles of ski slopes threading across the mountains. The whole idea is to turn Trojena into a one-of-a-kind attraction that people put on their must-visit list. You ski in the morning, hike in the afternoon, and spend the day by a huge artificial lake. That lake is supposed to be the main attraction of the resort, held in place by 3 giant dams. Building something like that on desert rock is tough. The ground can shift and leak, so everything has to be sealed and reinforced before the lake can even exist. But even if they build the entire complex, there's still a detail they can't ignore. This place doesn't get enough natural snow for any of it to work, not even close. That's why the entire project has to rely on machines or some advanced technology to produce most of the snow. Snow machines help by blowing cold air into the air, where it turns into tiny ice bits that cover the slopes. It works, but the sun in this region warms the ground fast, so the snow can soften or melt unless they constantly top it up. The machines also need a lot of water. Since this area doesn't have natural lakes or rivers, NEOM's plan is to pull in desalinated seawater from the Red Sea coast and push that fresh water through pipes and storage systems across all its zones, including mountain areas. That needs long pipes and strong pumps, plus a steady power supply so nothing shuts down when it gets hot. And even with all that, the air still has to be cool enough for snow to form properly. If it's too warm, the machines can spray all they want, but the snow won't stick. So engineers have to study the slopes and figure out which parts stay cooler and which parts heat up too fast. All of this takes a huge amount of electricity, and Trojena is supposed to get its power from NEOM's renewable energy system, which includes solar, wind, and stored energy. Solar sounds perfect because this region gets sun almost every day. But there is a catch. Panels like light, not extreme heat. When they get too hot, they produce less power, and that could happen right when the snow machines need steady energy the most. So the same sun that makes this place perfect for solar power can also make the panels lazier at the worst possible moment. All of this shows the basic plan, but how to sink everything in unpredictable heat is making engineers work overtime. And that challenge starts with the ground they're building on. Shifting soil or rock can delay progress or force redesigns. Then there's the problem of distance. The site is pretty far from major cities, so hauling materials to Trojena means dragging heavy equipment across miles of empty desert. Even with better roads, moving materials can still drag things down. A project of this size needs a huge workforce, special machinery, and advanced cooling systems, plus constant checks to keep everything running. Even with a massive budget, unexpected issues can pile up, so we have already seen slowdowns in other parts of NEOM. So Trojena could face the same problems. None of this means the project cannot succeed. It only shows how complicated it is to build something this big in a place that is not naturally made for what they're trying to create. When you put all the pieces together, it becomes clear why Trojena may be one of the most ambitious proposals ever. But what about some other engineering wonders that didn't seem possible at first? The Three Gorges Dam in China is one of those ideas that makes you pause and gasp. It stretches more than 7,500 feet across the Yangtze River and stands taller than the Statue of Liberty. To make it work, engineers moved over 1 million people and flooded entire valleys. When it finally started running, it became the largest hydroelectric power source in the world, sending electricity to millions of homes and helping protect cities downstream from dangerous floods. Another example is the Hong Kong-Zhuhai-Macau Bridge. It's one of the biggest sea crossings ever built and the longest sea bridge in the world, stretching almost 35 miles and linking Hong Kong, Zhuhai, and Macau. To build it, engineers had to deal with deep water, heavy ship traffic, storms, and strong currents. They drove huge piles into the seabed, built artificial islands, and even added an underwater tunnel so large ships could pass through. The goal was to allow cars and buses to cross the sea in one trip instead of taking ferries. When Qatar hosted the World Cup, it had to solve a serious heat problem. The summer weather there can make it hard to even stand outside, let alone play soccer. To keep players and fans safe, engineers built a cooling system under the seats, inside the walls, and around the field that pushes cold air across the pitch and lowered the temperature in the whole stadium. Cooling such a huge open space is much harder than cooling a normal building, but they still succeeded in turning this giant hot bowl of air into something closer to an air-conditioned arena. All these accomplished grand plans show that we should not write off Trojena yet. It has a few big things working in its favor. The budget is massive, the authorities are fully behind it, and NEOM is being built to support it with roads, energy, and workers. Whether they finish in time for the Winter Games is still a question, but if they do pull it off, Trojena could end up as one of the most famous tourist spots on the planet. The country's authorities are hiding something from you. They don't want ordinary people to ever find out the truth. You can see a lot of fake photos and false locations on the internet, but almost none of them are true. So what secret are they keeping? You definitely don't expect to hear this. They're hiding a tree. But it's not just a tree. Money grows on its branches. Can you believe it? Of course not, it's a joke. But the truth is, America does protect the oldest tree in the world, and its name is Methuselah. You can Google it and you will find a lot of fake pictures and some old gnarled aspens. Real photos of Methuselah are quite rare, and its location remains a mystery to this day. It's known to grow somewhere along the Methuselah Trail in the Inyo National Forest in California. It's a bristlecone pine tree, and its age is more than 4,600 years. Imagine how cool it would be to touch the trunk of that tree and feel all those thousands of years of history. Only it's not cool. This is the reason why the country is hiding its location. If thousands of tourists touched the tree and picked up small pieces of its branches, it wouldn't last even a month. Many trees in this area are pretty weak right now and suffering from drought and all kinds of bad insects. So Methuselah is also in danger. Don't touch or approach it, even if you find out the location. The tree was discovered by dendrochronologist Edmund Shulman. A dendrochronologist is a scientist who studies the rings of ancient trees, but more on that later. So Shulman discovered the tree in the middle of the previous century, and over the past 50 years, it has become shrouded in rumors and legends. But how did Shulman know it was the oldest? In 1957, he took a core sample and studied the tree's annual rings. You see, every year, a layer forms inside a tree, resembling a ring. But scientists don't cut the trunk, don't worry. They extract a piece as thick as a pencil, and that's enough. The more layers, the older the tree is. So, Shulman counted Methuselah's rings and found out that it's been growing for more than 4,600 years. This means it's even older than ancient giant redwoods, which were considered the oldest trees on the planet. In 1958, Shulman told the story about the existence of Methuselah and posted its photo in National Geographic. From that moment on, the tree became popular. Many people wanted to pluck a cone or twig from it, so the authorities forbade publishing information about the location of the tree. Later, other scientists examined Methuselah's rings and suggested it could be younger, though some rings were too faint or damaged to count. In any case, it remains the most ancient tree on Earth, officially confirmed that is. But it wasn't always like this. Back in 1964, a geographer, Donald R. Curry, stumbled upon a tree called Prometheus, which was about 5,000 years old. And you know what he did? He just cut it down. There are many theories about why he did it. The tool for getting core samples was broken, or this guy didn't know how to use it, but the result was sad. The tree didn't survive. Hopefully nothing like this will happen to Methuselah and it will live a long life. But why are scientists so worried about it? Yeah, it can tell a lot about the history of our planet. But is there another reason? There's a theory that this tree could live forever if no one cut it down, and droughts or parasites didn't destroy it. So basically, Methuselah's like nature's fountain of youth. Imagine if we could use that trick on people. Okay, now we know what the US hides, but do you know what Australia keeps secret? Not just a tree, but an island. Even if you were allowed to visit the island, it wouldn't be easy for you to get there. The island is located between Australia and Antarctica, somewhere in the middle of the ocean, but it's unlikely that you would get such permission. The fact is that Heard Island is completely untouched by humans, and Australia wants to keep it that way. You'll find little reliable information about this island on the internet. All we know is that the island has 2 active volcanoes, Australia's tallest mountain, and several glaciers. But you know what the coolest thing is? It's home to animals you won't find anywhere else. The island's closed ecosystem preserves creatures that might have never seen people. The next island is quite famous and is located in Brazil. The authorities don't keep it a secret, but they protect it from tourists. Even if you had permission to visit this place, you probably wouldn't want to. This is Snake Island, and its name speaks for itself. This piece of land contains the largest concentration of venomous snakes in the world. Those are golden lancehead pit vipers. One bite of this snake is critically dangerous for a person. The snakes are all over the place there and have almost no competition from other animals. Only specialists capable of handling these reptiles can visit the island. Lots of secret places stay off limits because humans can mess them up without meaning to. It's not that we're bad, it's just that even being there can change tiny invisible parts of nature. And here's a great example of the kind of destruction we can trigger. You've all seen photos of ancient cave paintings with horses and bulls. One of the most famous of such caves is the Lascaux Cave, which is located in France. On the walls inside the cave, people found more than 600 drawings and about 1,500 engravings. The 20,000-year-old drawings depicted different animals. Scientists opened the cave to the public, and this led to a disaster. Too many people came to see the cave, and it messed up the cave's ecosystem. Then a fungus showed up and started spreading over the walls, ruining the old drawings. It was a tragedy for the scientific world. The cave was quickly closed to visitors. Now, only a small group of archaeologists can enter it. No one knows when or if the cave will open again. Those glimpses of human history from the first European settlements might be lost to the public forever. Our next secret location is in Svalbard, Norwegian archipelago. This is the Svalbard Global Seed Vault, a massive storage vault that can keep 4.5 million seeds of different types. The authorities say that the seeds are stored there to preserve the population in case of a local disaster. But a lot of people think they're tucked away for the apocalypse, ready to help us replant Earth if everything goes wrong. But why, of all countries, did people decide to store seeds here? Because of Svalbard's cold, dry climate. The weather conditions here are ideal for seed preservation. The vault is well guarded, It's classified and no one can get inside except for authorized persons. All our secret places are connected with nature. An island, a forest, a cave. But how about finishing the video in the city? It's in plain sight, but it hides a secret room that is impossible to enter. In Atlanta, Georgia, inside a museum with top-notch security, the secret Coca-Cola recipe sits locked away in a massive safe. What? Yes, this is probably one of the most guarded secrets in the world. Money, diamonds, ancient artifacts. None of them get the kind of protection a single sheet of paper with the Coke recipe does. This secret has been kept there for more than 125 years. The unique storage design and security system make burglary almost impossible. You can visit a specialized museum and see the door to the vault, but nothing else. Sure, it sounds a little crazy to guard a single piece of paper, but then again, this drink has made the company billions. Coca-Cola has been one of the world's favorite drinks for over a century, and it's still raking in massive profits, so it's not surprising that its recipe is kept so secret.
Way down at the bottom of the world is so icy and remote that even asking, "Are there roads in Antarctica?" sounds silly. But the answer is not as simple as you'd think. It's not like no one gave it a shot. Back in the early 2000s, the United States gambled with Antarctica road construction on a massive scale. They tried creating a 1,000-mile ice highway meant to connect the coast to the middle of the continent. McMurdo, located on Ross Island, is the largest settlement in Antarctica. It works as a temporary home for up to 1,000 people during peak season. The South Pole Station is at the other end, and it's the southernmost spot where anyone lives. Basically, these two stations are the backbone of Antarctic logistics and supply routes. Usually, everything scientists needed at the pole had to be flown in, which is expensive and risky. One bad storm and the whole operation can be grounded for weeks. The ice highway was supposed to be a dependable overland route for transporting tons of supplies safely across the continent, even when planes were stuck on the ground. On the Antarctica map, it looks simple enough. Draw a straight line, smooth out some snow, and haul fuel and supplies instead of flying them in. It sounded ambitious, but well worth the effort. It could save millions in fuel alone. All they needed to do was keep the surface level. But beneath the snow was layers of soft powder and hidden crevasses, not to mention the constantly shifting ice that moved like a slow, frozen river. Bulldozers struggled and tractors moved slowly like slugs. Whenever the wind blew, the path they made was soon covered by fresh snow. It seemed to them like the continent was doing it on purpose. The crews working there lived in sled-mounted insulated modules and mobile shops. Their days started with engines chilled or stiff, requiring preheating before work. Doing laundry was one of the greatest challenges of the entire adventure. By the end of 2005, the route had its first full traverse, but the real challenge became maintaining it. The path runs through sheer zones, and new cracks open every season, forcing crews to rebuild and repair repeatedly. Eventually, it felt less like they were creating a road and more like they were just trying to keep up with the Antarctic weather and temperature. In the end, the highway wasn't exactly what it was supposed to be. But that doesn't mean it was a failure or a waste of time. Quite the contrary. What came out of the mission is what's now known as the South Pole Traverse. It's a seasonal land route that still supplies the pole today. It's not a road with asphalt or traffic signs, but it has become the most important route. Every southern summer, a small convoy of tracked tractors sets off from McMurdo Station, towing long trains of sleds toward the South Pole. They follow the same trail that the first crews carved out about 20 years ago. The route changes length every year and has grown from 1,028 miles to 1,030 miles. The journey takes from 25 to 40 days of steady crawling, hauling fuel and supplies that would otherwise require dozens of flights. This slow caravan saves millions and avoids weather risks. In the end, The Traverse turned out to be more than just a supply route. It was a testing ground for Antarctica infrastructure engineering. It became a proving ground for how to survey, groom, and maintain over-ice routes. But for now, the route survives only because people keep fighting to hold it together. Leave it alone for a season or two, and the ice will simply take it back. In Antarctica, abandoned equipment and structures can slowly vanish under accumulating ice and snow. Entire stations have become buried over decades, and some vehicles were rediscovered, partially buried and later lost from view again. As time goes on, snow and ice can build up so much that they can completely cover up machinery, making it difficult to find without some serious digging. At minus 76 degrees Fahrenheit, the cold becomes an engineer's nightmare. Jet fuel turns into jelly, batteries die within minutes, and steel becomes brittle enough to snap like a candy bar. In those temperatures, even breathing feels mechanical. Moisture from your breath freezes on your eyelashes, and any exposed skin can end up with frostbite very quickly. The ice is fascinating. It moves like a conveyor belt, carrying everything to the sea. Anything trapped in it, crates, vehicles, or even buildings, drifts slowly, sometimes miles away from where it began. And while the ice itself seems alive, there's other interesting geological stuff to discover. Close to some of these supply routes is Blood Falls, a waterfall flowing in a shocking blood-red stream. It's not a scene from a horror movie. The color comes from iron-rich, salty water trapped under the ice for millions of years, turning red the moment it hits the air. The continent has over 400 subglacial lakes that we know about, tucked away under thick ice. Many of these lakes fill and drain regularly, creating water flows that can make glaciers slide more easily and change how they move. It's also a gold mine for meteorite hunters. Thousands of meteorites are found each year on the ice. Antarctica isn't just a frozen wasteland. It's one gigantic outdoor laboratory. Scientists come here to study everything from climate change and atmospheric chemistry to cosmic rays and meteorites. Astronomers love it because of the bone-dry and stable air, perfect for telescopes that peer into deep space. Geologists dig through ancient rock formations that reveal how continents once fit together, while glaciologists drill deep into the ice to read Earth's past climates like pages in a frozen diary. Even biologists face the cold to study ancient resilient microbes and penguin colonies, hoping to understand how life survives in the harshest conditions on the planet. The few people who live here, mostly researchers, engineers, and mechanics, move around like cautious astronauts. Every trip is logged and every mile planned. Without regular roads, getting around Antarctica takes a mix of creativity and stubbornness. Most roads are temporary snowpaths, flagged to avoid hidden drifts. Around McMurdo, short ice roads appear each season to haul cargo, then vanish as the ice melts. Antarctica's transportation challenges are the most unique on our planet. Regular vehicles just can't handle it out here. That's why most everything runs on tracks, crawling along at a jogger's pace while pulling sleds packed with supplies. Air travel is really what keeps things moving. Big cargo planes touch down on temporary runways made of packed snow or ice. There are also smaller ski-equipped aircraft, which is something you don't see every day. But when winter sets in, seasonal runways shift, crack, or drift and have to be re-established. Even the ships that bring in food and fuel each summer don't hang around. They cut a narrow path through the sea ice, unload, and get out before the ocean freezes up again. When resupply ships arrive, the crews rush to unload everything before the ocean refreezes, working around the clock. Everything gets stacked on the ice like a temporary warehouse that must disappear before the sea locks itself shut for the season. Antarctica is currently protected by the Antarctic Treaty System and the Madrid Protocol, which together classify the entire continent as a natural reserve devoted to peace and science. Those agreements ban mining, permanent development, and anything that could harm the environment. Right now, the tough conditions keep most people away, And that's a good thing for the environment. A permanent road could change everything. Bring in more tourists and more activity, and the ice would struggle to wipe away human presence. That's why even a short snow trail needs official approval. Every move is watched, and every footprint has to be justified. In the end, the better question isn't are there roads in Antarctica, but should there be? Every attempt to build one, from the Great Ice Highway to today's seasonal routes, proves expensive and even pointless. That's why Antarctica road construction today isn't about building something permanent. It's about keeping scientists supplied so they can make amazing discoveries, such as drilling ice cores that trap ancient air dating back 800,000 years.
Exclusive photographs, by far the best yet, are in from the Titanic. For most of this century, that huge...
When the first images of the Titanic shipwreck appeared in September 1985, the world stopped. People were glued to their TVs, watching the legendary ship reappear after more than 70 years. Where did the Titanic sink, you ask? It's located about 400 miles off the coast of Newfoundland, Canada. This so-called unsinkable ship rests in complete darkness, about 12,600 feet below the surface. Yep, that's how deep the Titanic is. But even after such a long fall down to the ocean floor, the front part, known as the bow, still looks surprisingly intact. I mean, the railings were still there, the anchor chains too, even the elegant curves of the hull you might recognize from old photos. But the news barely mentioned the stern back then, and there's a reason we still don't talk much about it. You see, these images were about more than just capturing mesmerizing and eerie footage. They were proof of what really happened when the Titanic sank. We were finally getting some answers about this 1912 disaster, when more than 1,600 people lost their lives. And before you Google how many people survived the Titanic, I'll tell you, 706. Among those survivors, several claimed they saw the ship break apart as it went down. Others insisted it sank in one piece, and in the end, investigators agreed with them. Back then, official reports concluded that Titanic had gone down intact. So, for 73 years, that was the official story, until we finally saw the Titanic at the bottom of the ocean. When the Titanic underwater photos were released, they confirmed it. Yes, the liner really did break apart as it sank. And if we've just seen those images of the bow, that means the stern must be around there too, right? Well, kind of. I mean, we did find it. It's located about 2,000 feet away from the bow, lying on the ocean floor. So yes, it exists. But why doesn't anyone ever talk about what happened to the stern of the Titanic? Well, there's a big reason for that. See, the bow, even after all the damage from hitting the seafloor, still looks recognizable. Many of its interiors are surprisingly well preserved, and it's lying as if the ship was continuing its voyage. But the stern is destroyed. Today it's more like a twisted tangle of steel that barely looks like a ship at all. Only the parts that are more resilient, like the propellers, reciprocating engines, and rudder, have managed to hold their shape. But the rest of the stern section is melting into the seafloor. Yet, to understand why it's in such a terrible state, we need to go back to that freezing night of April 15, 1912, the night of the Titanic wreck. Just hours before the tragedy, Titanic was still sailing smoothly across the cold North Atlantic. The stern was alive with people, families talking, music playing, life going on as usual. This is where the room for passengers with the cheapest tickets were located. That's why third-class travelers were also known as steerage passengers. But the stern wasn't only for passengers. It also contained many of the ship's storage areas, including cargo holds, baggage rooms, kitchens, crew quarters, and even the engineering spaces. And hold on to that info, it's going to be important in a second. So let's jump straight to when the liner struck the iceberg. As the bow began to sink, the stern slowly lifted out of the water, putting enormous strain on the middle of the ship. By around 2 in the morning, the lights on Titanic flickered and then went out. Moments later, the ship broke in two, and the bow disappeared beneath the waves. The stern briefly settled back on the water before rising again, this time almost vertical. It stayed upright for a few seconds and then began its final plunge. At about 2:20 in the morning, the stern vanished beneath the Atlantic. Titanic was gone. What was happening beneath the water were two completely different scenarios. First, the bow slowly filled with water and began to drift downward, almost sailing gently like a submarine. Because of that, it managed to keep its shape and stayed mostly intact. But Titanic's stern collapse was a whole different story. The stern was ripped wide open where the ship had split apart. Water rushed in through that open end at incredible speed. This sudden flooding made the stern plunge downward much faster than the bow. The rush of water created so much turbulence that pieces were ripped off and scattered all around the ocean floor. Now, remember what I said earlier about the spaces inside the stern? Those huge storage areas were wide open, and many of them contained air pockets. So when the stern section broke away, it still had compartments filled with trapped air. As it spun down into the depths, this increasing water pressure crushed those pockets one by one. The surrounding structure began to implode, scattering pieces of metal, furniture, statues, and passengers' belongings across the ocean floor. So many experts believe the immense water pressure made that section collapse as it sank, and that's why we can't see much of it today. And now you know the answer to the Titanic back section mystery. We don't talk about it much, simply because there's not much left to see. It's like the part of the Titanic story that's too broken or too painful to talk about openly. The side of the ship that truly feels lost. And sorry to say this, but that's the future of the bow, too. I mean, it won't be there forever. The iconic shape of the wreck is changing year after year, and not in a good way. The front part of the Titanic is deteriorating, and one day it'll be entirely gone. Down on the seabed, the Titanic faces enormous pressure, nearly 390 times greater than at the surface. The good news is there aren't any air pockets left inside the ship, so big implosions won't happen again. But the bad news is that the ship's own weight is now helping to tear it apart. As those 52,000 tons of steel slowly settle into the ocean floor, they twist and pull on the hull. Submersible missions have already spotted large cracks running through the steel plates, and even the decks themselves are starting to cave in. And there's something else. The wreck might look cool and spooky today, but that actually comes from a thick layer of bacteria and microbes covering it. The problem is, they're slowly eating the Titanic. Yep, most of the corrosion happening down there is caused by bacteria, and this is gradually weakening the entire structure. Steel plates, beams, and supports are getting thinner every year. Scientists estimate that the ship is losing between 0.13 and 0.2 tons of iron every single day. Still, even at that rate, the wreck won't vanish overnight. Experts believe it could take up to 420 years for the liner to disappear completely. Until then, we'll keep watching this sad but natural process unfold. Parts of the ship have been falling apart little by little since the night when Titanic sank. And a lot has already changed since we started taking underwater photos, like the railing sections that have dropped, and the ceiling in the captain's bathroom that's collapsed. That's why so many expeditions are now focused on capturing footage and detailed scans of the Titanic shipwreck, to preserve its memory before the ocean takes it all. It's our way of keeping the story alive, even as time and nature continue their quiet work. Maybe those hungry bacteria can take a break from their buffet, so that Titanic can rest in peace with many more years to come. Now, this tiny town on a U.S. map used to exist only on paper, literally. Agloe was never built, never had a mayor, and yet, for a short while, it was officially on the map. Back in the 1930s, two map makers from American's General Drafting Company were hired to make a map of New York State. But they wanted to protect their work from copycats. So they created a ghost town and named it after themselves, Otto G. Lindbergh and Ernest Alpers. Take their initials, mix them up a bit, and you get Agloe, Or is it aglow? Well, no one's quite sure, since it never existed anyways. You see, creating fake towns used to be a thing, because copying maps was also a thing. In the past, map making was serious business, and protecting your work wasn't easy. So cartographers got clever. They started adding tiny traps, fake streets, made-up lakes, even whole towns to spot copycats. These sneaky details were called trap streets or paper towns. If someone copied your map, they'd copy your invention too. It was a quiet way of saying, "Busted," and then taking them straight to court. Then the funniest thing happened. A few years later, another company published a map with aglow on it. When confronted, they said, "It's not fake. There's a general store called the Aglow General Store right there." Turns out, someone had seen the town's name on a map and decided to open a shop under it. Today, the store is gone, and Aglow is back to being just a lonely road intersection in the Catskills. Now sometimes fake lands appear on USA maps not on purpose, but because of simple cartography mistakes. Take Isle Filippo, for example. This mysterious island with a fancy name was once proudly shown on maps of Lake Superior, even though it never existed. Back in the 18th century, French travelers were busy exploring the Great Lakes when they saw, or thought they saw, 4 islands out there. Let's just say their methods weren't always precise. But a French cartographer named Jacques-Nicolas Belin didn't know that. He trusted their travel notes and drew Isle Philippe on a map he made in 1744. The problem is that other map makers trusted Belin's work and copied the island onto their maps too. Before long, Island Filippo was as real as any place could be, on paper at least. It stayed on official maps, confusing travelers all the way into the 1820s. That's when explorers finally checked and realized, wait, there's nothing here but open water. Today, historians think the whole thing was a mix-up. The explorers probably confused it with Isle Royale, a real island that's part of Michigan. They were described as 2 islands about the same size, but there was only one all along. Next stop, Nothing. You heard that right, Nothing is the real name of a tiny ghost town in Arizona. If you ever drive down Route 93 between Wickiup and Wickenburg, keep an eye on the towers along the way. On one of them, there used to be a wooden sign painted in red letters that simply said nothing. Hopefully it's still there. This spot marks what's left of a once hopeful settlement in the middle of the blazing desert. Back in 1977, a man named Richard Buddy Kenworthy decided to found his own town. He built nothing out of almost nothing. The place had a gas station and a tiny convenience store, but that was it. Then he added a big yellow sign that proudly declared, "The Town of Nothing, Arizona. Population 4." And yep, that was its peak, only 4 inhabitants. I know your family dinner table might have seen bigger crowds. But anyway, in May of 2005, Kenworthy packed up and left, and Nothing was officially abandoned. 3 years later, its famous gas station began to crumble. But some fans, I guess we can call them that, decided to bring Nothing back to life. There was even a small pizza place running there for a while, but it didn't last long. By 2011, Nothing was, well, nothing again. And today, it's one of the most famous abandoned towns in the USA. Now, speaking of abandoned towns, some were lost to time, others to something far more dangerous, like Centralia, Pennsylvania. From a distance, everything looks fine, but take a closer look, and you'll notice something strange. Roads cracked open, smoke rising from the ground, and no people in sight. That's because Centralia isn't just abandoned. It's been on fire for more than 60 years. It all started back in 1962. Although there were many theories about how the fire began, the results are well known. The flames spread into the labyrinth of coal mining tunnels running beneath the town, causing devastation as they went. Fissures opened in the ground, sending plumes of smoke and toxic gases into the air, and the fire never stopped. That's right. At first, no one thought much of it, especially because everything was happening underground, out of sight. But soon, smoke began seeping up through the soil. Then, in 1981, a huge sinkhole suddenly opened under the feet of a 12-year-old boy. Thankfully, he grabbed onto a tree root and survived. But that was all the proof locals needed that the fire wasn't going away. Experts warned that the underground blaze could keep burning for more than 250 years. And that's why most of Centralia's 1,000 residents decided it was time to pack up and leave. Today, fewer than 10 people still live there, refusing to move. The rest is nearly a ghost town, with empty streets and crumbling foundations. They don't even have a zip code anymore. Beneath it all, the coal is still burning quietly, making Centralia one of the eeriest forgotten towns in America. And now you might be wondering, how many more of these towns are out there in the U.S.? Well, a lot. Just in Texas alone, there are an estimated 511 ghost towns that are now completely deserted. Then there's Nevada, believed to be home to over 600 phantom towns, many of them left behind after the gold and silver rushes of the 1800s and 1900s. People moved there to work in the mines, and when the mines shut down, they left. But abandoned towns and mapping errors aren't just a U.S. thing. Even in the age of satellites and Google Earth, fake cities still manage to sneak onto maps all over the world. One of the most famous modern examples is a place called Argleton. Back in 2008, a guy named Mike Nolan was checking out Google Maps, looking around the area where he grew up, in West Lancashire, England. Then he spotted a city called Argleton, but something felt off. He remembered that spot being just a farmer's field near the village hall. Maybe a footpath crossed it, but that was about it. There was definitely no real city out there. And he was right. It was a total mistake. Nobody knows exactly how it got there, but it did. Don't bother looking for it, though. Argleton was officially removed from Google Maps by May 2010. And even if you look for its old coordinates today, you'd only see an empty, muddy field. Alright, so Argleton might have been fake, but it sure had a lot of fans. When people first discovered it online, they went a little wild. And then came all the jokes. People were actually selling souvenirs that said, "I visited Argleton and all I got was this t-shirt." Some local restaurants even offered Argleton pie, and the ingredients were, well, nothing. Believe it or not, even today you can still find merch online celebrating the world's most famous Google Phantom Town. Well, that's the end of our tour of the strangest ghost towns on the maps of the USA, and even beyond. So, tell me, have you ever been to an abandoned city before? Have you ever discovered hidden places on the map that shouldn't even exist? Well, share your story in the comments below. In recent years, street lights across the U.S. have started glowing a weird violet hue that nobody could explain. And before you think we've slipped into a parallel reality, there's a much simpler explanation. It's a technical problem, and a rather eerie one. It all started in 2021. Back then, at least 300 streetlights that had been installed in Milwaukee began glowing with a purple hue. People described it as giving off a sort of an eerie cyberpunk vibe. That was definitely not good, especially for authorities, who had to figure out a plan to fix them quickly. Replacing all those lights was going to take about 10 weeks. Plus, the crews weren't exactly thrilled about braving Milwaukee's freezing December weather to get the job done. But the problem wasn't just happening there. Month after month, people in places like Kansas, South Carolina, Illinois, and Florida said they were experiencing the same thing. Of course, this kind of news is a goldmine for folks who love a good unsolved case. Soon enough, online detectives jumped in, and theories started flooding the internet. Like, maybe the lights were supposed to repel mosquitoes, or they were releasing chemicals for some unknown reason. And my personal favorite? That Prince's ghost was taking control of those streetlights. You know, like Purple Rain? Anyway, none of that made any sense. Because the truth is that purple hue isn't intentional. It's actually the result of an interesting and somewhat aesthetic failure in some LED chips. You see, from the very beginning of streetlights in the US, the whole idea was to keep things safe and make lighting more efficient. That's how we went from simple oil lamps to gas lamps and through a bunch of other attempts until we finally ended up with electric lighting. Then, about 15 years ago, cities across America started switching their streetlights from sodium lamps to LEDs. And that changed the color of many nighttime roads from a yellowish-orange tone to a bright white. Now this change makes total sense. LEDs are one of the most energy-efficient lighting technologies out there. Let's take an old light bulb, for example. With this one, 90% of its energy turns into heat, not light. But if we look at an LED bulb, it's the opposite. Only about 10 to 20% of its energy becomes heat, and the rest goes into producing light. They also last way longer. Now, LED stands for light-emitting diode. These tiny diodes can shine in all kinds of colors. But one color they don't naturally produce is white. So, when you see white LEDs, like the ones in streetlights and probably inside your own home, they're actually pulling off a clever trick on your eyes. To make white light, you could mix tiny dots of red, green, and blue LEDs together until they blend into white, kind of like mixing paint colors on an artist's palette. That's one way to do it. But there's another, more popular and energy-saving method that's usually used in streetlights. Instead of using 3 colors, manufacturers often start with just blue LEDs. But they coat these blue LEDs with a special fluorescent substance called phosphor. When the bright blue light from the LED hits this layer of yellow silicone phosphor, some of the blue light gets absorbed and transformed into red and yellow light. These new colors mix together with the remaining blue light, and voila! The glow looks white to our eyes. Now, you might be asking, why go through all this trouble? Well, making LEDs shine red and green takes more energy than simply making them shine blue. So, sticking with blue LEDs and using phosphor saves electricity. Plus, it's simpler and cheaper because it needs less complicated wiring and few different LED chips. It's a win-win for cities trying to keep costs down and lights on. Of course, this phosphor trick doesn't work for everything. TVs and color-changing light bulbs need to produce many colors precisely, so they still use separate red, green, and blue LEDs. But when it comes to simply lighting up a street in white light, the blue LED plus phosphor method is the favorite choice. Normally, this technique works really well for streetlights, and the materials manufacturers use to make phosphor are extremely stable. But since this weird purple phenomenon is all over the internet, there's no denying that this is happening. So, specialists had to start looking for a cause. It turns out the phosphor coating had probably worn off or hadn't been applied correctly in the first place. Over time, the phosphor layer in some LED devices can start to break down, and without that yellowish filter, they end up shining more blue, giving them a purple glow instead of white. And the reason the problem only showed up after 2021 is because a specific batch of new streetlights that got installed all over the country. Thankfully, it seems like lighting manufacturers have figured out the issue. As a result, you're unlikely to see this problem come back in the next few years. And there you have it. No conspiracies, no Prince's ghost. Too bad. Just a little bit of color-mixing wizardry gone wrong. And little by little, the signature purple glow started disappearing as lamps slowly failed or got replaced. Now that's too bad for fans of the purple lights. Yeah, there have been plenty of reports from people who thought they looked nice. They felt the purple glow gave off enough light to see without being so bright that it hurt their eyes. But in the end, the lights had to be replaced for safety reasons. After all, streetlights are supposed to help you see when it gets dark outside, and the purple lights just aren't very good at that. Some people even had their houses broken into and blamed the poor lighting for making their neighborhoods feel more vulnerable. And then there's driver safety, too. The color of the light shining on a roadway can change the way drivers see their surroundings as they make their way through the night. So inside your eyeballs are tiny helpers called photoreceptors. They come in 2 types, cones and rods. Think of cones as your daytime buddies. They love bright light and are the reason you can see all the beautiful colors around you. But when the sun goes down and things get dim, cones start slacking off. That's when the rods step in to save the day, or rather the night. Rods are the night shift workers of your eyes. They're super sensitive and help you see in low light, even if everything looks more like shades of gray than full color. But here's the thing. Rods are extra good at picking up light from the blue part of the spectrum. In other words, bluish light stands out more to your rods than other colors do in the dark. Now, most rods hang out in the outer edges of your retina, the part of your eye responsible for peripheral vision. So, when you're driving at night under bluish streetlights and you suddenly catch a hint of motion out of the corner of your eye, that's your rods doing their job. Under bluish light, they're even quicker to spot things moving around in your periphery than they would be under yellowish white lights. That boost in your peripheral vision under bluish light comes with a bit of a trade-off. Sure, your rods are great for spotting movement out of the corner of your eye, but the moment you try to look straight at whatever is moving, bam, it can suddenly get harder to see and focus. So it's not super safe for drivers. Okay, but does the purple glow actually affect our eyesight or cause any long-term problems? Manufacturers say we can rest easy because this effect is harmless. I mean, there's no evidence that anyone's been hurt by it. But it's true that blue light scatters more easily than most other visible light and can make it harder for your eyes to focus, especially in low light conditions. So, yeah, I guess we can all be glad that this purple lighting is finally going back to white. See? There's something curious about Scotland when seen from above. An almost perfectly straight line cuts right across the country from coast to coast. You might have never noticed, but that giant scar has existed for hundreds of millions of years. And right along its path lies one of Earth's biggest mysteries, the Loch Ness Monster. Meet the Great Glen Fault. Just like other major fault zones around the world, it was born because of the movement of Earth's tectonic plates. So let's go back in time, like 430 million years ago. At that point, a massive geological drama was going on called the Caledonian Orogeny. Now, orogeny is just a fancy scientific word for how mountains are formed. So, this whole region looked totally different back then. There were these three ancient continents called Laurentia, Baltica, and Avalonia. Think of them like, giant puzzle pieces slowly floating around on Earth's surface. Over millions of years, these enormous chunks of land drifted and eventually smashed into each other. When they collided, the edges of the continents crumpled and folded, kind of like a piece of paper bunching up when you push it from both sides. But some scientists believe the continents didn't just crash straight into each other. Instead, they started sliding sideways past one another. Imagine pressing your fingertips together and rubbing your hands back and forth. That sideways motion is what scientists call a strike-slip fault. What I mean is, these massive blocks of rock move side to side rather than up and down. So, bit by bit, the land on either side of the fault kept inching past each other, shifting by several miles over geologic time. During the late Cretaceous to early Tertiary, which happened roughly 66 million years ago, the region shifted once again. This time, scientists believe the land's displacement was about 64 miles. Then, the ice ages came along. Rivers and glaciers found that giant crack in the earth and dug it out even more, making it deeper and wider. That's how they carved out the lakes that follow the fault's path. Finally, dump all of that into a geological blender, and there you have it, the Great Glen Fault in all of its majestic glory today. Yep, all that movement of the land helped sculpt the mountains and deep valleys that shape the highlands as we see now. Now, the interesting thing is, the story of the Great Glen Fault doesn't stop in Scotland. This scar in Earth's crust actually has a secret twin across the ocean. The fault probably continues on the other side of the North Atlantic, over in North America. But over there, it's no longer one continuous crack. About 200 million years ago, Earth decided to shake things up. That's when the Mid-Atlantic Ridge began forming, basically a giant underwater mountain range that started pushing the continents apart and broke the original fault. So now, the North American side of the Great Glen Fault shows up as what is now called the Cabot Fault, also known as the Long Range Fault. It slices through the length of northwestern Newfoundland in Canada and even stretches out into the Gulf of St. Lawrence. Meanwhile, back in Scotland, the fault lines up perfectly with the Great Glen, a valley about 62 miles long, stretching from Inverness in the northeast all the way to Fort William. And it's filled with gorgeous lochs. One of the largest and most famous of these lochs, of course, is Loch Ness. Yes, I'm talking about the Loch Ness. that mysterious stretch of water that's said to be home to the Loch Ness Monster. You know, the legendary creature with the long neck that likes to poke out of the water every now and then, and that sends shivers down the spines of anyone lucky or unlucky enough to catch a glimpse. At least, that's what people say. But despite many years of searching for the creature, everything from thermal imaging drones to miniature submarines, no one has found any real evidence of the monster. And one interesting fact is that the Loch Ness Monster might be directly linked to the Great Glen Fault. Some geologists think that plenty of Nessie sightings might actually be, well, just simple bubbles, big ones, and they were probably caused by the fault itself. The thing is, all the movement in this region hasn't been confined to millions of years ago. Over the past 150 years or so, there have been occasional moderate earthquakes rumbling through the highlands. When the fault lines shift, even just a tiny bit, they can release gas pockets trapped underground. Then, rising gas bubbles can disturb the surface of a lake, creating ripples, waves, or sudden bursts of movement across the water. And that's exactly the kind of thing that might look to someone standing on the shore like a giant creature swimming just beneath the surface. But in reality, it could simply be the Earth shifting by a fraction of an inch along that ancient fault. Or, as I like to put it, the lake has farted. Big question, is this region still moving? I mean, is this big geological map actually getting bigger nowadays? Well, it's hard to say, because scientists don't all agree. Some researchers think the Great Glen Fault is still active today. They consider it a reactivated strike-slip fault, meaning there might still be some action happening deep underground. The rocks on either side might still be straining and inching past each other. And in fact, occasional moderate tremors have been recorded over the past 150 years, usually with magnitudes of around 3 or 4. But not everyone is convinced. Other scientists point out that there is no solid evidence of significant modern activity along the main fault, and the seismic activity over the past few centuries hasn't been strong enough to prove the fault is seriously on the move. Take the Inverness earthquake that happened in 1901, for instance. To this day, it's considered one of the strongest that ever happened in Scotland. People felt it all across the country, and the earthquake damaged several buildings in Inverness. The situation was so intense that it gave the feeling of, oh boy, this crack is definitely growing. But the specialists aren't so convinced. Some believe it likely happened on a secondary fault connected to the Great Glen Fault, but not directly on the main fault itself. So, once again, it's hard to say for sure whether the Great Glen Fault is still actively moving today. Despite all the different studies and debates over many years, there are only a few conclusions about this huge gap that everyone agrees on. The fault is unusually straight, it is super ancient, and it is extremely deep by any standards. That's not the only cool fact about Scotland's territory, though. Let's travel to the islands that lie off the northwest coast of the mainland, to the Isle of Skye. This place was once home to a wide variety of dinosaurs during the Middle Jurassic period. The thing is, finding dinosaur fossils from this time period is super rare, but the Isle of Skye is an exception. Specialists discovered that about 167 million years ago, give or take, dinosaurs were mingling on the muddy edges of a warm lagoon over there. As they gathered around this ancient watering hole, they left behind layers of overlapping footprints. Specialists first noticed these tracks in the early 1890s, but at the time, they concluded that the impressions were petrified burrows of ancient fish. But then, in 2019, a graduate student from the University of Edinburgh went there and figured, nah, these are definitely three-toed dinosaur footprints. And he was right. Over several years of fieldwork, he and his colleagues discovered more than 130 individual prints. The team believes that the tracks were left by megalosaurs. These were large dinosaurs, around 20 feet long, and they were serious meat eaters. In fact, they sat right at the top of the local food chain during the Middle Jurassic. But at the time those footprints were made, these big boys probably weren't hunting prey. No, their tracks show that they were just walking around, wandering in different directions, probably hanging out near the water. And this spot is so special because it gives us a rare peek into what life was like in the Jurassic period.
A giant crack, more than 2,000 miles long, is splitting open across Africa. Roads, houses, even schools are getting torn apart. Now, scientists think they've finally figured out what's causing it. An enormous column of scorching hot rock called superplume, rising from deep inside the Earth. And it's slowly pushing the land apart inch by inch. This isn't a small shift, though. The continent is breaking in two, and the clue to what's going on could be hidden thousands of miles away in Hawaii. And why does the United States suddenly have a role in all of this? Hang on, we'll get there. First, it's important to know this isn't new information. Africa has been slowly splitting for about 25 million years. This is happening in a region called the East African Rift System. It stretches thousands of miles from Ethiopia down to Mozambique and is the largest active continental rift system on the planet. And by that, I mean places where the Earth's crust is being stretched and pulled apart, causing faults, earthquakes, and volcanic eruptions. Scary stuff, to say the least. Back in 2018, for example, a massive crack appeared near a small town just west of Kenya's capital, Nairobi. In some spots, it was about 65 feet wide. That's almost the length of two school buses parked one after the other. The whole thing was terrifying. It happened fast and left a trail of destruction. Roads were cut off, farms torn apart. People were on edge as the ground opened up beneath their feet. And I mean that quite literally. One man watched the crack rip straight through his home. He barely had time to grab a few of his belongings before his entire house collapsed. Sounds terrifying, right? Since it happened in the East African Rift region, panic spread fast. The media was all over it, claiming it was proof that Africa is splitting apart. People standing near the crack thought, oh boy, it's already happening. And many still believe that today. But that's not actually the case. At least not with that particular crack. Because after the initial panic, videos and photos of it revealed clues that it wasn't related to tectonic plate movement. First clue, the two sides of the crack didn't match. Like trying to fit the wrong puzzle pieces together. They simply didn't line up. Second clue, the gap wasn't one continuous line. There was some kind of soiled bridges in between. All this showed it was sudden erosion. I mean, some specialists believe the crack had once been filled with volcanic ash from nearby Mount Longonot. But then the region was hit with heavy rains. When water soaked through the soil, it washed the ash away, leaving the gap exposed. Problem solved. Even after the truth came out, it was too late. This event brought the whole Africa is splitting talk back. And here's the thing. Even though that crack had nothing to do with it, make no mistake, Africa is breaking apart. That's because the continent sits between two tectonic plates, the Somali plate in the east and the Nubian plate in the west. The problem is they're moving away from each other, and as they drift apart, the gap in the East African Rift keeps getting wider. Eventually, the Somali plate could split completely from the Nubian plate, creating an entirely new landmass, something on the scale of Madagascar or even New Zealand. You don't have to worry though. This process is super slow. So slow that none of us will see it finished. Experts say the continent is moving apart by about 0.3 inches a year in some places. To give you an idea, that's less than the length of your fingernail. So we can say this split will take millions of years, which is good news for the people living there. But that doesn't mean they won't feel the effects of this slow break. In fact, they're already happening. Take Ethiopia's Afar region, for example. Back in 2005, this area showed just how unpredictable the rift can be. In a short period, 420 earthquakes hit the area, opening up a massive fissure. What usually takes centuries happened in just a few days, completely challenging what scientists thought they knew about the speed of geological changes. Back then, the crack stretched for more than 35 miles, and life around it is still far from easy. Recent earthquakes destroyed much of the local infrastructure. 37 schools were damaged, leaving 5,000 students without classrooms. And that was just one part of the damage. As the tectonic plates keep moving apart, water will eventually flood into this region, creating a brand new ocean, according to some predictions. Countries like Zambia and Uganda, which are landlocked today, could one day have a coastline. That could be great news for them, as it might open up new trade routes and completely reshape their economies. Don't get too excited though. We won't be diving into the waters of this sixth ocean anytime soon. The splitting process will take another 5 to 10 million years. But it's tough to say exactly when, since big seismic events, like earthquakes, could make it all happen faster. So here's what we know. The Somali Plate and the Nubian Plate are in the middle of a dramatic tectonic breakup, slowly moving apart. Africa is breaking in two. Earth will probably gain a new ocean because of it. But until recently, we didn't know exactly what was triggering all of this. Like, yeah, those tectonic plates are moving, but why? I mean, is this massive geological process being driven by something happening in Earth's mantle? Or could it have a much larger, deeper source? Well, scientists think they may have finally cracked the mystery. They believe the continent is breaking apart because there's a deep mantle superplume, a huge column of hot rock beneath the East African Rift System. Think of it as a massive subterranean hammer pushing upward, pressing against the crust, and slowly cracking it apart. But here's the interesting thing. Scientists reached that conclusion thanks to something that happened in a completely different part of the world, Hawaii. Under this US state, there's also a plume of super hot rock rising from deep inside the planet. It melts the crust above it, and that's what fuels Hawaii's volcanoes. As the Pacific Plate drifts over this plume, molten rock breaks through in new spots, creating volcano after volcano. Over millions of years, that's how the Hawaiian Islands were formed. This Hawaiian plume contains noble gases like helium and neon. And you know where else scientists found those same gases? That's right, beneath the East African Rift System. Bingo! That discovery backed up the theory that a superplume is driving what's happening in Africa. And we call it super because it might be massive. You see, these same gases have been found in volcanic rocks from Kenya all the way down to Malawi. So everything points to the existence of a single superplume that stretches from the Indian Ocean to the Red Sea, not a bunch of several isolated sources. If their data and research are correct, scientists estimate that this superplume beneath Africa likely starts at the core mantle boundary, which is located about 1,800 miles deep inside the Earth. While the East African Rift System's chemical signatures are similar to those found in volcanic rocks in Hawaii, they're not identical. The Hawaiian plume is thought to be a narrow, rising stream of hot mantle, a bit like the movement inside a lava lamp. Africa's plume might be shaped differently, more like a large mass of hot, buoyant material rising from deep within the Earth. As it reaches the surface, this hot material hits the colder, solid outer layer and spreads out, pushing hard enough to crack it open and trigger intense volcanic activity across the region. And if this theory is right, we're watching a slow but unstoppable force that will redraw Africa's map and change the continent forever.
Okay, let's just say you're driving home and suddenly your GPS freezes. Your phone says you've got full bars, but it takes forever to make a call. Or maybe the call drops for no reason and you have to redial. You brush it off. Probably just your carrier being weird. But then, later, during a house party, your light flickers for a second. No need to panic, you're not haunted by a ghost. At least I hope not. No, it's much more likely that the sun is acting up. Because a giant hole about 500,000 miles wide opened in its atmosphere, and now it's sending strange stuff straight at us on Earth. Okay, so what does that even mean, a hole in the sun? Well, when we look at the sun with highly protective sunglasses, of course, all we can see is a bright, calm star. But that couldn't be further from the truth. Up close, it's total chaos. Its surface boils with magnetic storms. Loops of plasma twist and snap, and every now and then, the outer layer, called the corona, becomes unpredictable. That's what happened recently when a massive region of the Sun's atmosphere suddenly changed shape. So scientists call it a coronal hole, but don't picture a crack or a crater. It's more like an open vent in the Sun's outer layer. Our star has these invisible forces running through it, like tension lines beneath the surface. Most of the time, they loop back on themselves, but sometimes, in certain spots, they stretch outward into space like open lanes. And that's when stuff starts flying. Particles shoot out at crazy speeds in what we call the solar wind. This wind hurls through space at about 1 million miles per hour, which is fast enough to reach Earth in a few days. The area of the Sun where the wind comes from looks darker and cooler than the rest of it. That's why we call it a coronal hole. And the current one is huge, so big that you could fit about 62 Earths side by side. It stretches across a massive chunk of the Sun's southern hemisphere and is pointed straight at our planet. So, what exactly is the Sun sending our way, and what happens when it gets here? Well, solar wind isn't just fast. It's also packed with tiny charged particles the Sun hurls out when it's feeling active. And when that stream runs into Earth's magnetic field, it's like tossing a rock into a still pond. It presses against our planet's magnetic shield, distorting it like a balloon being poked from the outside. That's what creates these breathtaking auroras. However, sometimes, the Sun takes it even further. Instead of a steady stream, it blasts out a massive cloud of solar material all at once. That's called a coronal mass ejection, or CME. This can mess with GPS and jam signals, as partly because of something called the ionosphere, a charged layer way up in Earth's atmosphere that helps radio signals travel. When that layer gets disturbed, signals start bouncing weirdly or dropping out completely. In late May 2025, Earth was hit by a geomagnetic storm. It was classified as a G3, which means strong. It came from a stream of high-speed solar wind released by a coronal hole and caused visible auroras as far south as Iowa and Oregon. Warnings issued pointed to GPS and shortwave radio disruptions during the storm, but no serious issues were reported. Just a few days later, the situation got worse. On June 1st and 2nd, another storm happened. This time, it was a G4 class. That one is considered a severe level event, just one step below the highest category. The skies lit up. People across the northern U.S., and even as far south as California and New Mexico, saw glowing curtains of green and pink across the night sky. It's the kind of thing you normally have to travel to the Arctic or Antarctic Circle to see. Okay, fine, I'm convinced. Ghosts don't do this stuff. But it wasn't just a light show, although even astronauts aboard the International Space Station were able to capture breathtaking pictures. Airlines received radiation warnings and may have altered some flight paths as a precaution. Satellite operators were monitoring for signal drift, and high-frequency radio used by ships, planes, and amateur operators could have experienced brief disruptions. But then came another one. A few weeks later, in mid-June, Earth was hit by a G2-class geomagnetic storm. It wasn't as intense as the earlier G4 event, which meant less risk for disruptions and another chance to catch glowing skies on camera. Then, just to keep things interesting, the Sun followed it up with a pair of powerful solar flares on June 17th and 19th. Solar flares are distinct kinds of outbursts, but with similar consequences. The Sun's surface is constantly moving, dragging magnetic fields around like tangled cords. Eventually, those lines get twisted so tightly that they snap, and that snap is what causes a solar flare. If a CME is the Sun launching materials, a solar flare is more like the Sun flipping a light switch, except the light is radiation, which floods space at the speed of, well, light. Flares hit fast, sometimes within minutes, and they don't need to carry particles to cause problems. So, while CMEs are like massive clouds of solar blasts that take a day or two to arrive, solar flares are the flash that hits you before you even see it coming. And in mid-June, Earth got hit with two of them, one after another. The second one was the stronger one and briefly knocked out radio communications across parts of the U.S. Why is all this happening? It's not random. The sun follows a pattern. It goes through phases, kind of like moods. Yeah, solar moods. Every 11 years or so, it gets a little dramatic. More flares, more sunspots, more weirdness. Scientists call this peak period the solar maximum, and we are currently in the middle of one. Right now, we're in solar cycle 25, which is expected to peak sometime between now and early 2026. During this time, the sun's getting active. It seems like things are just starting to heat up, and we can expect even wilder storms in the coming months. But if that's the case, should we be worried? Well, not really. At least not in a run-for-the-bunkers kind of way. Solar storms don't hurt people directly. You're not going to get sunburned through your roof or microwaved in your sleep. Unless they announce a beautiful aurora, you won't even know it happened. The bigger concern is for the systems quietly running in the background: satellites, navigation networks, and electricity. When the magnetic field gets disturbed, it can cause electric currents to form on the ground. And those currents don't just stay underground, they can sneak into power lines. If those currents get strong enough, they can overload transformers, damage electrical systems, and even knock out entire power grids. That's what happened in Quebec in 1989, when a solar storm blacked out the whole province in 90 seconds. So that's why agencies like NASA and NOAA track solar activity constantly. They know when something's headed our way, how strong it might be, and what kind of warnings to send out. Now, we usually don't think about the sun unless it's too hot or messing with our beach plans, huh? Or when it's freezing and we're stuck indoors, dreaming of summer. But occasionally, it reminds us that it's still a wild thing. A fascinating ball of chaos. It flares, it erupts, it throws giant waves of charged particles across space just to see what happens. And even from 93 million miles away, we feel it. A dropped signal, a beautiful glowing sky, a power flicker. Little hints that we're not as disconnected from space as we'd like to believe. So, the next time your GPS acts weird or your screen glitches for no reason, don't blame your phone or Casper. It just might be the sun feeling moody again.
In Asia, there's a bridge that is way longer than you'd think should even be possible. The HZMB stretches 34 miles over open water, which makes it the longest sea bridge in the world. So if something this massive can make it across rough waters, why can't New Zealand just build a bridge between its two main islands? After all, we're talking about a distance of just 14 miles. And a bridge like that could seriously change life for both locals and tourists. People could just hop in a car and drive from Wellington to Picton. No more ferry hassles, no more drawn-out trips. Just one epic road journey with ocean views on both sides. So what's stopping them? Well, turns out, everything. I mean, building a bridge there is technically possible, but there are a couple reasons why experts are like, maybe not. Let's start with the obvious, the distance. The North Island and the South Island are separated by Cook Strait. Like I said, it's 14 miles wide at its narrowest point. That's not much, true. Plus, we've got the HZMB bridge, proving that, yep, it is technically possible to build a bridge over the sea to cover that distance. But we can't ignore the fact that New Zealand's geography is, well, a whole different ballgame. Cook Strait isn't exactly a calm, friendly stretch of water. It's deep, really deep. Parts of it drop to about 10,000 feet. That's like stacking 7 Empire State Buildings on top of each other. It's also a rough, moody stretch of ocean that loves tossing around ships like rubber ducks. In fact, quite a few have been wrecked in Cook Strait. And sadly, many lives were lost. You don't have to worry about it so much though, as the worst accidents happened a long time ago. The ships and ferries that cross it today are much safer. Even so, it'd be pretty hard to avoid getting seasick while crossing it. Things get even messier below the surface. The seafloor over there is uneven and unpredictable. What happens is that Cook Strait has opposing tides at each end. one where it meets the Tasman Sea and the other where it joins the Pacific Ocean. And they simply don't move together like you might expect. When the tide is high on one side, it's low on the other, and they're totally out of sync. So all that water rushes back and forth through the strait to balance things out, creating some really strong and messy currents in the middle. Then there's the weather. Cook Strait isn't just windy, it's probably one of the windiest places in the southern hemisphere. That's because it's located right in the middle of one of New Zealand's 3 big wind tunnels. Basically, there are places where the wind doesn't just come and go quickly. It sticks around, blowing hard for most of the year. And all of this happens because of something called the Roaring Forties. That's the name for the latitude band between 40 and 50 degrees south of the equator, where strong, persistent westerly winds are pretty common. Unlike the northern hemisphere, which has a lot of land at this latitude, the southern hemisphere is mostly ocean with just a few land masses, like New Zealand's South Island, Tasmania, and the southern tip of South America. So, these winds go wild because there's nothing to slow them down, and they just keep picking up speed. The gusts there can reach up to 150 miles per hour. So, imagine trying to cross a bridge in a car when the wind is actively pushing against you. That's not just unpleasant, it's super dangerous. Drivers can easily lose control of their cars with the wind pushing them sideways. And of course, that can lead to countless serious accidents. Now, let's talk about earthquakes. New Zealand sits right on the boundary of 2 massive tectonic plates, the Indo-Australian and Pacific plates. It's basically in the middle of a collision zone. And about 14,000 earthquakes happen in and around the country every year. Of those, only about 200 are big enough to be felt. Still, building a massive bridge under these conditions would require some serious genius-level engineering. With all that in mind, we can safely say that the whole bridge idea is off the table. But how about an underwater tunnel? Yep, that could work. It could be a great solution actually. No wind, no bad weather, and no earthquakes to deal with. There are a bunch of other advantages too. First, it would dramatically reduce travel time, cutting down the 3 to 4 hour sailing trip between the North and South Islands. That same journey would probably only take about 40 minutes. Then people wouldn't have to stress about all the ferry cancellations and delays because of bad weather. And most importantly, it's doable. I mean, look at the Channel Tunnel. It's an undersea tunnel connecting southern England and northern France. Japan did something similar with the Seikan Tunnel, which connects the islands of Honshu and Hokkaido. They are both huge projects, serving pretty much the same purpose. So why on earth isn't New Zealand already building this tunnel? Well, for the same reason we don't all live in luxury treehouses with personal robots: money. Estimates vary, but some experts think a project like this could cost anywhere from $10 to $20 billion. To cover that kind of cost, they'd probably need to charge tolls for the next 100 years. And trust me, those tolls wouldn't be cheap. Other experts think it could actually cost more than that. Because you see, we have to consider all the extra infrastructure. The narrowest point of Cook Strait is between the North Island and Arapawa Island. That's one of the long, mountainous regions in the Marlborough Sounds, which is pretty remote. So it's not just about the cost of the bridge or tunnel itself, it's also the access roads, safety systems, maintenance, and evacuation plans. You can't just build a huge underwater tunnel and not plan for the occasional emergencies. And what would it actually be used for? Sure, there are people who travel between the islands. About 1 million passengers take the ferry every year. But that's not exactly the kind of traffic that justifies the most expensive infrastructure project in the country's history. Earlier, we talked about how England and Japan have similar underwater tunnels. But there's something to consider. The United Kingdom has a population of 69 million. Japan has even more, with around 123 million people. And in New Zealand, they've only got 5 million residents to pay for this project. So could they have a tunnel under Cook Strait? Sure they could. Should they? Probably not. If you don't want to fly, the only other way to travel between the islands is by ferry. It's not ideal, but hey, it works. New Zealand has a total of 5 ships that transport people and vehicles across the islands. For tourists who aren't in a rush, it's perfect. You can cross the islands while taking in some of the most stunning views and spotting amazing wildlife. You'll start your trip in Wellington, and right from there, you'll see the rugged North Island coastline as you head out into open water. You might see different seabirds like gulls and terns, and as you get closer to the South Island, you might spot some gannets. If you're lucky, you could also catch a glimpse of the seal colonies off the coast. During the last hour of the trip, the ferry will slow down, giving you plenty of time to enjoy the green hills and calm waters. You will also approach Queen Charlotte Sound, a spot known for its wildlife. So keep an eye out for orcas, playful dolphins, and even penguins. Honestly, having a ferry instead of a tunnel might not be so bad after all.
You know what? The Netherlands deserves a resilience Nobel, and I can prove it. Exhibit A. About a quarter of the country is below sea level, and half of it sits just 3 feet above. The highest point down south only reaches about 1,000 feet. That's like the height of the Eiffel Tower. Exhibit B. It's the 7th lowest country on the planet and one of the most densely populated. Nearly 4 million people live below sea level. And yet, they're totally fine. No scuba gear needed to get to work. Exhibit C. It's located right next to the North Sea, with massive rivers pouring into it from all over Europe. The Rhine, the Meuse, and the Scheldt rivers, all of them empty into the sea through the Netherlands. Now, with all that going on, this country should be under the ocean by now. And yet, it's not. In fact, they're not just staying afloat, they are expanding. But how? Well, I'm going to tell you. This is what the Netherlands looks like today, but this is what it looked like back in the 14th century. Now compare these two, and you'll see that most of the land we see now used to be underwater. Take Schiphol Airport. It's the 4th busiest in Europe and probably the one you flew into if you've ever been to Amsterdam. It was built on what used to be a lake, the Haarlemmer Lake to be exact. But they drained it back in 1852, and now the airport sits over 13 feet below sea level. This isn't an isolated case, though. For the past 2,000 years, people there have been fighting tirelessly to push the ocean back and keep the water out of the land. They started by building things like canals, huge winding waterways that channel excess water away from low-lying areas. And then there are the windmills. Yep, I'm talking about those classic cute Dutch windmills that are a tourist landmark. But they're not just for pictures. These things actually use wind power to pump water out during heavy rains or floods, sending it into the right channels where it can be safely drained. Most people in the Netherlands also depend on dikes to keep the water at bay. These massive barriers act like the country's giant walls, stopping water from flooding into the land. But if something goes wrong, like if the water rises higher than the dike or the dike gets damaged, then people living nearby are in serious danger. But hey, at least their wooden shoes would float. Oops, never mind. But for now, let's say the rewards totally make the risks worth it. I mean, thanks to all these efforts over centuries, the Dutch have managed to reclaim 20% of their land from the sea. The biggest difference is wonderfully clear in Rotterdam. What started as a small settlement along a peat river back in the 14th century is now a city with the largest seaport in Europe. Check out this whole section here. This piece of land, for example, was added in just 4 years. So, how did they make land out of nothing? Well, in this case, they used these huge dredging ships, the same kind they used to build those insane Palm Islands in Dubai. These ships suck up sand from the ocean floor like a giant vacuum cleaner, and then spray it onto certain areas to create new land. Once they had enough sand piled up and shaped just the way they wanted, they had to make sure it wouldn't get washed away by the sea again. So they brought in around 20,000 massive stone blocks and placed them all around the edges, like building a giant protective wall. No doubt the Netherlands is one of Europe's most innovative countries when it comes to tackling rising waters. One of their biggest successes is probably the Maaslandkering, a storm surge barrier in South Holland. This engineering marvel was built in the 90s with one goal in mind: to take the full brunt of tidal surges from the sea. So whenever the water is expected to rise 10 feet or more, this barrier automatically closes. And just like that, it protects 1.5 million people. That doesn't mean it closes all the time, though. In fact, it's pretty rare. In 25 years, this barrier has only closed twice. But with ocean waters rising twice as fast now as they did in the 20th century, experts think this barrier is going to be closing a lot more often in the future. The good news is, it's built to keep protecting the country for the next 100 years, and it can handle a 16-foot rise in ocean water before they will even need to think about making any major changes. Okay, we get it. The Netherlands is doing an awesome job keeping the water out. But what if, one day, they just can't handle it anymore and end up flooded? What could things look like by the year 2100, for example? Well, this is how much of the country could be underwater in a worst-case scenario. It would push people to move further inland, more to the east and south of the country. That would be a huge challenge, though. If that happened today, authorities would have to squeeze over 18 million people into a much smaller area. So they'd have to think up some serious urban solutions. Those cute, cozy little Dutch houses, you know, the ones with 2 or 3 floors, would be replaced by massive skyscrapers just to fit everyone in. So, farming might go vertical. People would start growing food in tall buildings instead of sprawling fields. And most every rooftop would have some kind of green space, like a garden or a park, so people can still enjoy nature even if they're stuck in the middle of a busy city. To protect historic buildings, places like Amsterdam would have huge raised dikes surrounding them. But even with all that, life would still change big time. People wouldn't really live on the ground floor anymore, since it would be too risky with the flooding. Those lower levels would stay empty, and they would start building new rooms or living spaces up top. They'd also be raised walkways connecting everything, kind of like a whole new ground level in the sky. Boats and small water transport would become normal for getting around. And experts even think we'd still have super-fast trains running through big dikes to connect all the cities. So yeah, even in a crazy apocalyptic scenario, the Netherlands would still survive a massive flood. They just need to adapt. But what's fascinating is that water isn't just something the Dutch fight against. It's also something they completely rely on, especially when it comes to business and trade. Because the Netherlands sits right on the North Sea and has all these rivers, like I mentioned at the beginning of the video, remember? It became this natural hub for shipping and trading centuries ago. It's like Europe's gateway for goods. And since the Netherlands is the world's second largest exporter of foods and agricultural products by value, that's critical for them. Take the port of Rotterdam, for example. It is huge, one of the biggest and busiest ports in the world and easily the largest in Europe. It's like the ultimate pit stop for cargo ships coming in and out of the continent. So much stuff moves through there: containers, oil, cars, food, you name it. Water makes it super easy to move things around, not just within the Netherlands, but to places like Germany, Belgium, and France too. Barges on the rivers are essentially the Dutch version of 18-wheeler trucks. So yeah, while they've worked hard to keep the water out, they've also made it work for them economically in a big way. Now, let's talk about Dutch chocolate. Wait, I've run out of time. Maybe later. Bye for now.
Name a desert. Let me guess. Sahara? Well, actually, no matter which one you thought of, I'm sure of one thing. It's located somewhere below this line. See, when we hear the word deserts, we usually picture dry, sandy, blazing hot places, and there's not a single one of those above 45 degrees north latitude, or below 45 degrees south. In the south, that kind of makes sense. I mean, if you leave out Antarctica, there's not a whole lot of land down there. But things are different above 45 degrees north. There are tons of land. Countries like Canada, France, the United Kingdom, and a bunch of others. And still, not a single desert. Actually, not a hot desert. Most of the major hot deserts are up in the northern hemisphere, near the tropics of Cancer and Capricorn. And the hottest ones are usually found between 15 and 30 degrees north or south of the equator. Just like the Sahara, where average high temperatures can reach up to 104 degrees Fahrenheit. Together, hot deserts cover almost 15% of the Earth's land area. But if our planet is packed with them, why doesn't a single one appear above this line? I mean, the 45 degrees north latitude. I'll explain. Let's divide Earth into 5 main zones. The polar regions are located at both ends, north and south. Right here, we have the 2 temperate zones. And finally, right in the middle of the globe is the tropical zone. Now, the line we're talking about sits in the temperate zone, in a colder area. Because the farther you go away from the equator, the colder it gets. Actually, the average annual temperature drops about 1.2 degrees Fahrenheit for every degree of latitude you move north in the northern hemisphere. And cold weather is the main reason hot deserts don't form above this line. It turns out that as you move farther north from the equator, the sun's rays hit the Earth at a more slanted angle. That spreads the solar energy over a larger area, which means less heat is concentrated in one spot. Basically, these regions just don't get as hot. And it's one of the reasons why countries like Finland are much colder than Colombia, for example. Another reason temperatures are lower in this zone has to do with something called albedo. Basically, this term refers to the amount of sunlight that a surface reflects back. Let me give you an example. Every surface on Earth both reflects and absorbs sunlight, but in different amounts. Take snow, for example. It can reflect up to 90% of the sunlight that hits it and only absorbs about 10%. That's what gives snow a high albedo. And it's totally different with sand, which has a lower albedo. In places like the Kalahari Desert, down in southern Africa, it's about a 50-50 situation. Most of the year, roughly 50% of the sunlight gets reflected around there, and the other 50% is absorbed. The heat absorbed by the sand is part of why it gets so hot in dry places like deserts. I mean, hot deserts. Simply put, sand soaks up more heat, while snow reflects most of it. This is one of the reasons why snowy areas stay much cooler. So the closer you get to the polar zones, the easier it is for sunlight to be reflected instead of absorbed. And that helps explain why there aren't any hot deserts around those parts. Then, we also have atmospheric patterns. Let's just say that the air patterns change a lot once you go above that 45-degree line. That's because this region is controlled by a wind belt known as the Ferrel Cell. Okay, so Earth has 3 main convection cells. You can think of them as big loops of moving air. Warm air rises, cools down, sinks, and then the cycle repeats. At the top and bottom of the planet, we have the polar cells. Right in the middle are the Hadley cells, and sandwiched between those two are the Ferrel cells. Now, everything that happens between these 3 cells can get a little complicated, but for today, the main thing to know is this. In those middle zones, the warm air that comes from the tropics meets the cold air from the polar regions. So, Ferrel cells play a big role in moving heat from the equator up toward the poles. This flow of warm air helps smooth out the temperature differences between the tropics and the polar regions. And that's what shapes the weather in places like North America, Europe, and parts of Asia. In the mid-latitudes, the Ferrel cell keeps the air moving around so much that hot, dry air doesn't really get a chance to settle. So, those regions end up with more moisture, more clouds, and even storms, rather than dry, desert-like weather. That's why you don't usually see hot deserts around 45 degrees latitude. Basically, what I'm trying to say is that the Ferrel cell makes the weather less stable. And that's very different from what happens in the Sahara Desert, for example. Over there, temperatures don't change all that much throughout the year. Just expect it to be hot. When you put all these factors together, it helps explain why hot deserts are mostly limited to the middle parts of the Earth, and why you'll never find a Sahara or Kalahari-style desert in places like Canada or Sweden. But that doesn't mean we don't have any deserts above the 45-degree line. Turns out, deserts don't always have to be hot and sandy. In fact, they can look like this. Yep, I'm talking about the Arctic. Because the actual definition of a desert isn't just some hot, dry, sandy place, it's really any area that gets very little precipitation. In other words, an area where it doesn't rain much. And it usually gets no more than 10 inches of precipitation per year. So no matter if the weather is hot or cold, deserts are really dry places with hardly any vegetation around. That makes it pretty tough for animals and plants to live in those environments. If you think about it, that means the biggest desert on Earth is Antarctica. It covers about 5.5 million square miles, just endless ice flats as far as the eye can see. It's also the coldest desert on the planet, even colder than the Arctic, which is the other polar desert. Temperatures there can drop as low as minus 128.2 degrees Fahrenheit. If you look at the Earth, about 33% of its land is desert. Now, pay close attention to the ones located between 15 and 30 degrees latitude. These are called tropical deserts. But can you notice something curious about their locations? Most of them are found on the western edges of continents. And there's a reason for that. Actually, 4 main reasons. First, the winds that bring rain usually blow from the east. When they move across the land, they drop most of the rain early on. By the time these winds reach the west side, they're dry, so there's no rain left for those areas. That already makes things pretty dry. Second, in the western margins of continents, the air usually goes down instead of up. When air goes down, it gets warmer and can't form clouds, so again, no rain. Third, if there are mountains nearby, they can block the rain too. One side of the mountain gets all the moisture, and the other side, called the rain shadow, stays dry. And lastly, the ocean near these places often has cold water. Cold water cools the air above it and makes it calm, so clouds don't form easily. No clouds means no rain. So when you put all of that together, it helps explain why those tropical deserts seem to prefer one side of the continent more than the other. See how the Antarctic Peninsula looks just like South America, but upside down? This isn't just a coincidence. It's the ghost of a 30-million-year-old breakup. These continents were once connected, but their divorce gave birth to an ocean current so powerful it was capable of completely freezing Antarctica and shaping its landscape. Here's how it went down. Tectonic plates pulled a sneaky move and cracked open a ridiculously narrow passage in the ocean, about only 500 miles wide, forcing 4.5 trillion cubic feet of water to flow inside this geological straw. This was the birth of an ocean current stronger than the Amazon River. This ocean current, called the Antarctic Circumpolar Current, by the way, flows in a circular motion, going clockwise because of the strong winds that blow over there. This circular motion around Antarctica caused erosion, shaping the landmass of the continent into a circle, except for that stubborn peninsula, which is being slowly dragged east like a kid refusing to leave a playground. Wait, South America and Antarctica used to be one? Yep, a long time ago. South America, Australia, and Antarctica were all part of a supercontinent called Gondwana, which also included Africa at some point. Back then, South America and Antarctica used to be basically joined at the hip by a land bridge called the Antarctic Land Bridge, which just so happened to be a lush green forest and also a great dinosaur highway. Yeah, you heard it right. Dinosaurs. A 95-million-year-old dino, whose name I can't pronounce, sorry, was discovered in Australia, and scientists found out it had actually been a distant cousin of Argentina's Sarmientosaurus. Same jaw, same chisel teeth, same everything. These guys were like identical twins, separated by an ocean. How? Because back then, Antarctica wasn't a frozen wasteland. It was a temperate rainforest, like Oregon, making it a pretty nice travel route for a dino family. But the land bridge wasn't just for dinosaurs. About 40 million years ago, the ancestors of Australia's marsupials waddled to the land down under all the way from South America, taking the Antarctica route, another proof that these continents used to be connected. Things remained somewhat peaceful for the dinos and the marsupials until Earth's ground started moving. This is what a German scientist called the continental drift theory, back in 1912. Our German friend here basically looked at the coast of South America and went, "Hey, this looks like it could fit into the coast of Africa." Like a scientific Sherlock Holmes, he noticed what others had overlooked for centuries. The continents were clearly pieces of a larger puzzle. And he was right. Here's the deal. Planet Earth is made of many layers of rocks and metals, like a cosmic onion. The outermost layer, the lithosphere, is divided into pretty solid tectonic plates that move atop a layer of softer, somewhat molten rocks, like slippery ice. This is why the plates move. In fact, they've been rearranging Earth's face for billions of years, with supercontinents forming and breaking apart in cycles, like a slow-motion game of bumper cars. This movement might be pretty slow since most tectonic plates only move 0 to 3.9 inches every year, except for the Nazca Plate, racing ahead at 7.8 inches, about as fast as your hair grows. But don't let their snail's pace fool you. These shifting slabs are the ultimate planet shapers. Their slow dance gives us everything from earthquakes that build mountains, like the Himalayas, to rifts that birth oceans, like the Atlantic. All because the oceanic crust is dense and sinks like a stone, while continental crust floats like a cork. It's this density difference that explains why continents exist at all. Without it, Earth would be completely covered by shallow seas. This slow-motion planetary renovation project is exactly what tore South America and Antarctica apart 30 million years ago. The plates under these continents started to drift apart in a process called crustal extension. It's like the lithosphere was pizza dough being slowly stretched until it thins and splits. As the crust stretched, it became thinner and weaker, eventually cracking like the surface of a drying lake bed. This whole thing gave birth to a new tectonic plate, the Scotia Plate, that emerged between South America and Antarctica, like a geological divorce lawyer. For a while, parts of this plate stayed above water as the last gasp of the Antarctic land bridge. It was Earth's version of that one thread still connecting your hoodie after the zipper breaks. These final connections might have persisted as chains of islands, but just like that fraying hoodie, the connection couldn't last forever. Eventually, this small but mighty plate became the final nail in the coffin of the land bridge connecting the two continents. Just like all the tectonic plates, this one was also on the move. As it expanded eastward, it opened a new passage of water called the Drake Passage, slowly covering the Antarctic land bridge with ocean water. The process was like pulling open elevator doors. At first, just a crack, then wider and wider until the connection was completely broken. This geographical divorce had chilling consequences. The new Drake Passage allowed the Antarctic circumpolar current to form, creating an endless loop of cold water that isolated Antarctica, shaped its land, and even cooled the entire planet. This current acts like a wall around Antarctica, blocking warm water and invasive species while regulating global climate. Eventually, Antarctica turned into an icebox that is 98% covered in ice sheets, and that holds about 61% of Earth's fresh water. Nowadays, this continent holds the title of the windiest, driest, and iciest place on Earth. It's a frozen desert where temperatures plunge below -128.6 degrees Fahrenheit, cold enough to freeze your breath mid-air. A layer of ice there can be more than a mile thick, and it expands even further in winter to cover an area larger than the continental United States. Today, if you want to travel to Antarctica, the quickest sea route is through the Drake Passage, a 500-mile-wide body of water that is narrow enough for the winds to scream across thousands of miles, transforming into monstrous waves that can tower up to 49 feet, though calm days create waves only 13 to 16 feet high. Still twice as tall as Atlantic waves, mind you. This is probably why sailors call this stretch of ocean the Drake Shake. But tectonic movement isn't just about shifting continents. It's Earth's ultimate life support system. You see, about half of our planet's heat comes from radioactive decay in the core. Thanks, uranium-235. Something like nature's nuclear reactor. This heat is behind everything from volcanoes to the very plate motion that once connected Antarctica to South America. And it only comes out of the core because of tectonic movement. Without this internal heat engine, Earth would be just like Mars. When the plates move and release heat, they also release CO2 gases into the atmosphere, regulating the temperature of our planet. And when the plates move underwater, they take a lot of this CO2 back to Earth's interior, recycling all this gas. This is why the plates can change our air, climate, and even the evolution of life itself just by moving around. But billions of years ago, these plates were not moving around. Back then, it was like Earth was wearing a solid ceramic shell with many cracks. But even without tectonic movement, the heat managed to escape through these cracks in a process called stagnant lid tectonics, kickstarting all life on Earth. And no, tectonic movement is not a thing of the past. Earthquakes are the living proof that it is not just happening today, but might repeat again on a more dramatic scale in the future. You see, to form supercontinents like Pangaea, smaller megacontinents have to dive beneath another. And scientists predict that a similar process might create a new supercontinent called Pangaea Proxima in 250 million years. By then, humans might be extinct or living on Mars, but Earth's tectonic dance will continue, even without us. Not bad for something that moves more slowly than a traffic jam. Turns out, Antarctica and South America used to be BFFs before all that tectonic drama split them up, like a messy breakup that literally froze one of them out. Now, they just awkwardly mirror each other from across the Drake Passage. Classic exes.
That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.